Okay, I just recorded a 50-minute video of me faffing about trying to figure out which PDF editor to use. Now I have the actual editor installed. Let's read. Let us read. Yeah, so I'm using Ocular for those who care. But the article is "How Can You Be So Certain" by Bjarne Stroustrup. And this is a bit of a double video because not only will I be reading this article, I mean double task, but I'll also be no Discord and open. I will also be using it as an excuse to try out my new Zettelkasten system. Yesterday, I recorded a 7-hour video. 7-hour video, by the way, of me literally I was literally just trying to learn how to use a Zettelkasten and set one up in Obsidian. But I feel like I have it okay. The issue is like with these notes here, these notes are not fresh. Instead, I took my existing notes and like converted them into Zettelkasten form. So like these are examples of those, and I feel like they're okay, but I think it's better if I start by actually creating genuine Zettelkasten notes from scratch. So then I have a clearer like framework. Because as I put it in my last recording, you cannot create the transformation function if you do not know what you are transforming to. Yep, so good I had to say it twice. So yeah. And for my PDF, I got this because I needed because the Vivaldi not Firefox, Chrome PDF viewer is kind of just lacking. And all I really need is just the ability to highlight specific text like this, and the ability to, if I go on browse mode, to view notes or like attach notes to highlights. So like here, I have red, which is for questions, and then you can see here I have the note like what. And the way this will work is that if I have any questions, I'll just highlight them, and then later on at the end of the article, I'll see if I can answer them. If I can't answer them, then I will of course include that in my Obsidian notes on this material. But if I can't answer them, then great, I've learned something. So obviously that's a good way to engage. So I got that, and then yellow, and yeah, yellow is for just like key things. So like let's say this is like a great quote. I don't know. Then I'll highlight that. I'll highlight that and then literally verbatim copy paste it into my source note on Obsidian. I don't have any source notes right now, but they would just like contain basically just a summary of the whole text and then reference like things I can reference in my commentary notes. So that's the idea. Anyway, my keybinds are working again. Okay, I don't know why they stopped working. So I can use 1, 2, 3 to cycle between these. Well, by cycle I mean like specifically select, and then Control 1 to browse, Control 4 for text select. I'd like to change my text selection though, from to something else. I prefer if 1 was for text selection, and then the rest of these were for these. But I don't seem to have the ability to customize that. That would actually be a fairly easy thing to modify, because Ocular is open source software, so like nothing is stopping me from building it from for me trying to build it from source and then modifying it. So I might give that a try sometime. But for now, let me just go to my settings real quick. I don't want to spend too long customizing because I want to actually just dedicate this recording to the article. So let's search for text selection. Right now it's Control 4. Okay, annotation. Yeah. So I can't change. Wait, manage schemes. No, I can't really change that, but I can change text selection. So for text selection, I'll just change it to 1, 2, 3, 4. Control, yeah, Control 4 is like a bit hard to reach. Can I do? Yeah. So okay, how about Alt? What's Alt 4? Alt 4 is strikeout. So I'm just gonna remove that. Yeah, just none. And then replace what? Yeah, and then replace text selection. So 1, 2, 3. Actually, I guess I could just make it 4, can't I? Is that allowed? So 1, 2, 3, 4. Okay, we'll see how that works. Yep. So let's just read on. So often I miss the careful weighing of pros and cons. Often I wonder what our weighing of evidence. Sorry, I just jumped ahead. So sorry, so this article, how can you be so certain, by Bjarne Stroustrup, the creator of C++. This stuck out to me because, as I often find, programming it's not just about writing code. It has links to psychology and philosophy, and I find it very interesting that Bjarne himself seemingly wrote this opinion article as a paper. So yeah, I'd love to see what he has to say about it. I already read this part, but he read a book, and the quote was, "Say not, this is the truth, but so it seems to me to be, as I now see the things I think I see." From David Love. A bit convoluted, I agree, but it got him thinking. I've often wondered how some people could be as certain as they seem to be, and I also wonder this, as someone who cares passionately about like critical thinking and finding the truth, like the truth of, well, a system really. Because like, can you know absolute truth? Maybe not, but like at least like facts within a system. Um, Certainty is a very harrowing thing. It almost like it's a real plague on my existence. How other people can be so certain about things that they shouldn't really be certain about if they don't know that much about it, or like don't have like evidence to back it up. Like that's like my real, not just pet peeve, but like the bane of my existence. Like a goal of mine in this life is literally to make people question their certainty. Like that would just be huge for the development of society. Because like racism, is like, for instance, like racism is a form of um unjustified certainty. Because like you see someone, you like, I mean, like, fair enough, like your brain recognizes patterns as it should, right? We should be good at seeing patterns, but then to just assume that person is the stereotype because because you've had this preconception and like you're certain they're like that, that's bad. And certainty can be both conscious and subconscious as well, you know. So very 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 interesting. Yeah. So we are far better technicians than we were in the early days of the committee, but I'm concerned that our discussions of major changes are somewhat superficial. Sometimes I miss the rigor of a peer-reviewed academic paper. The paper is at least partly based on empirical observations. That is, and my question was, what kind of empirical observations? And I like this title. We need to think harder. In fact, I might even just make a note of that, right? Instead of just saying it, we need to think harder. And then I guess I can like make a note about this too. So we need to think harder. Um, yeah, I mean, I just kind of agree. Um, Often I wonder whether our weighing of evidence is thorough enough, consistent enough, and even if it pays attention to concerns that cut across the complete language and standard library. I think so is not a technical argument. My company does it is not a conclusive argument. I badly need it is not a conclusive argument. All modern languages have it is not a conclusive argument. We can implement it. It's a necessary but not sufficient reason to accept a feature, and most people in the room liked it. Is not a sufficient reason. Yeah, I mean these. Yeah, great. Um, I'm just thinking if I highlighted this, I should probably give some kind of context as to why. Like obviously it like stands out to me, but like many things stand out to me. Why this in particular? We need to think harder. I guess what's interesting about this is the imperative language. Um, imperative tone is interesting. Well, Okay, but why? Imperative tone, right? Needs. Needs. And also, like, to what end? Like, for what goal? But that's a question. So now I have a red inside a yellow. So actually, in that case, I might just change this. So let's Control Z to try to remove the text selection, the highlight, I mean. Okay, whatever. So we need to think harder. Yeah. For what goal? For what purpose? Why is it an imperative need? Okay. I think so. Okay. I think so is not a technical argument. Yeah. I mean, these are kind of obvious. The one here that stands out to me is all modern languages have it, and for this one, I need it. Like, would it? Like, I'm guessing it would be conclusive if the person explains why they need it. In fact, the same probably goes for all of these surface arguments, to be fair. Uh, which means I actually want to change the color again. That's interesting. How I keep switching between colors when I get, because yeah, okay. All modern languages have it. It's not a conclusive argument. So okay, so should I even separate the colors then, or should I just use one? Okay, you know what, chat? I'm gonna use red for thoughts and yellow just for quotes. Not really though. Okay, fine. I'll use yellow for thoughts, which can include questions, but like the pink will be specifically for like just questions, like just straight up. I'm not entirely sure what they mean by this. Hopefully they elaborate. So like I get what he's saying here, or I can guess it anyway. This one is also interesting. All modern languages have it. Because this is an argument often made with like Rust and stuff. Particularly interesting since Rust, since languages, well, since more modern languages like Rust and Zig, and even before languages like Java led to people requesting features for C++ that weren't necessarily um, well designed or fitting to C++ without serious um, improvement. If that makes sense. Okay, well, not serious, but like improvement. And I hope that as I practice like this note taking, my notes themselves will make more sense. And I think that'll come from me reading my notes as well. Like as I read my notes, I realize, God damn, I suck at this. So then that will be like a motivation because I'm reading it. So like I need to understand it. So hopefully that's good. We can implement it is a necessary but not sufficient reason to accept a feature. Yep. Like add it just like okay. So this is also interesting, right? Because just because you can doesn't mean you should. And this is particularly important in the case of C++, since it has no system for deprecating or moving old features. Rust, on the other hand, has additions and therefore may be more equipped for such. Try it. Well, okay, like fuck around and no throwing shit. No, like it's it's not throwing shit at the wall, but it's like for such experimentation, right? Just use formal language. Oh my god. Okay. Most people in the room liked it. Is not a sufficient reason. Okay. Why not? That's my question though. Let me just get some water. Sorry. I said that like it was like miles away. I just need to get my foot's a bit dry. The last point may seem anti-democratic, but it is not. Which room? We're the people representative of the committee membership. See, he thinks like a psychologist. I love this. Bjarne, my goat. Of the C++ community? What did they like? What were their reasons for liking it? Who was against? Why were they against? People in a room are typically self-selected, and the proponents of extensions are usually far more motivated and articulate the supporters of status quo. Yeah. That's a great point. Yeah. I'm just like, cause like obviously, people have their heroes and stuff, but like I'm just shocked that the creator of a language. I mean, obviously, I have my issues with C++, but for the most part, I am a fan of C++'s style, and I'm just like so surprised. I mean, pleasantly surprised that the creator of C++, who like created it back in the day, is actually like a thoughtful person who still contributes to the language. And like even from the beginning, as I read Bjorn's like commentaries on the language, like I realize there are features that are now being added that he supposedly wanted to add like years ago. Like even like pre 2000s, like at his conception, there are features he wanted to add, but they were either not feasible or that he wasn't able to do it because of C compatibility. Like that's crazy to me, and just so cool. It's like how many? Because like usually when you imagine a language designer who like can just like makes a language and then the language like I guess over time gets more and more complex, in a bad way, like messy, like C plus plus can be. Like you think that it's like the creator like had an idea, you know, implemented it, and then people kind of like took it over, and then like now they just whatever. But no, like Brian's like genuinely involved in like these new things. Like I read his article on um, reflection or no, sorry, pattern matching. And then like I saw like talks like his talk on concepts like it's just so cool. It's so cool because like concept it's a C++ 20 feature, C++20 feature, but he's wanted it for a lot longer. And his pattern matching paper that we read, that I read in the previous video, was from 2014. 2014. Like Rust came out in what, like the 2000s? If not the 2010s. I can't remember the exact year. Like that's insane. Like talk about ahead of his time, really. Um, yeah. I mean, like, I could make a note like here, like saying, "Wow, Bjorn actually thinks like a psychologist," but I don't know if that's the kind of thing that would go in a Zettelkasten. Like, it's evidence if I ever wanted to like bring it up in a discussion, right? Bjarne Stroustrup has a psychological thinking scientific mind. Um, yeah, like I guess thinking about what I would do with my notes, like that's the kind of article I would make. Although I don't know if I want to just glaze glaze the man. Um, okay, for some reason my keybinds just stopped working. Like it works for this, but the 1 2 3 doesn't, and I'm not entirely sure why. Okay, so I click on the page. How do I deselect? Okay, nice. So the last part might seem undemocratic, but it's not which room. Yeah. What, bro? Why can't? Why is it text selecting? Hello? I wanna edit. Okay, this might be a bit cooked. I can't lie. Um, Bjarne continues to surprise me with his critical thinking and scientific approach. Like like his scientific approach to thinking about language design and implementation, as people should. He employs thinking that I first saw formally outlined in psychology, and is the kind of thinking that science, or like that fields of research in general would benefit massively from if more people adopted them. Um, Not to say that I doubted Bjarne. Well, no, like not to say that I looked down on Bjarne. That's weird. Like look down on? Obviously not. That I didn't think Bjarne was that kind of person, but rather I was worried that he wouldn't be, especially after meeting other programmers online. Well, not even online, but like especially after meeting other programmers over time, or like over the years. Especially after having met Bjarne, continues like Bjarne, not even met, like having listened to other programmers and computer scientists over the years. I had a very high image of Bjarne since he's the creator of C++, and I'm glad that that image is actually justified from what I've seen so far. Although obviously I must remain skeptical, as always. So on a practical level, I think that simply adding up votes and seeing if there is a 3-1 majority is a mistake. Yeah, we need such a majority. We need such a majority, and preferably more for consensus. But it's not. But it is not sufficient, especially not when there are relatively few people in the room, when it's late in the week and people are tired, and when key and/or long-serving members are elsewhere. That's interesting. This actually highlights something else. It is always worth considering who are strongly against and why. Neither strong proponents nor strong opponents are necessarily right. Sometimes strong emotions hide a lack of logical arguments. We are defining a language for decades of use. A bit of humility is necessary. Um, okay, from this, he doesn't say it, at least not yet. Um, yeah, this is interesting because it's saying something about um, yeah. There's a bigger statement about how like in the moment okay about in the moment decisions in general, and how they do not allow, and how requiring a decision in such a quick time frame. It could be a couple of days or even a matter of seconds. Um, is excludes, right, a lot of potential for better decision making. I'm aware that this text is really small, by the way. Like this text here on the notes. I'm not really sure what I can do to change that right now, but well. Oh well, I'm reading it out loud anyway. Yeah, I think yeah, I'm gonna zoom in here. Remember when it was popular to have all functions be members? Ooh, was it? I mean, I'm old enough, but also sorry. This we are defining a language for decades of use. A bit of humility is necessary. Humility. I mean, it's a cool quote, like banger writing. But like, is that like would I add a cool quote to my Zettelkasten? Not unless I had something to say about it. We're defining a language for decades of use. A bit of humility is necessary. Also, he says humility. Like, why? Like, humility in what sense? Like, put yourself aside and think of the wider thingies, implications. Okay. I'll say, hmm, yellow isn't a thought per se. Okay, I might do it like this then. Like, yellow is bigger ideas that aren't specific to the text, and then the red or the pink, whatever, is like ideas that are specific to the text. Yeah, sorry, what the hell? Like, yellow is like stuff that's like, okay, I mean, obviously I'm inferring from the text, like these ideas, but like the ideas can be taken away from the text, whereas the pink is more like meta. Like, I wonder why he used humility. Well, okay, this word specifically. Like, I wonder why he takes, why, yeah, why he not defines, but like applies humility, or like applies this definition to humility. Okay, I wonder what he means by humility in this context. Like, is it the ability to put yourself and your emotions aside and think about the bigger picture? Because I mean, that would make sense, but it's like, yeah, it's a question. I don't need to be too deep with the wording. It was popular to have FHP members. Yeah, and now it's funny enough, we're actually moving away from member functions because we're realizing that it's better to treat data as data. I mean, I say we, like the data-oriented programming gang crowd, um, would agree that it's better to treat data as data and then like have functions be transformations on the data, whereas having functions be inside the classes, yes, it gives you like a mental model. Like, it's an abstraction, right? Obviously, but if you're writing like data-oriented programs that they want to be performant and low level, it's not an accurate representation of what's actually happening. Like, if you were to um like, let's say I had a class, right, with like three member variables and like five methods, right? If you were to ask me, like a few months ago, how would that class look if I were to create an instance of it on the stack, right? because I've been doing like reverse engineering, so these are things that I need to learn about. And yeah, like I didn't really know. Like I assumed that okay, well, I guess actually it's just the member variables that go on the stack, but then the functions like are the functions like on the stack as well as function pointers, or are they just completely like separate from the class itself? I mean, even now, I'm not sure. I think it's just the variables and the methods are separate, but and like having it inside the class is just syntactic sugar for having a implicit self and namespace. But I don't know. I generally don't know, which is a bit concerning. Like that abstraction feels like obviously it's zero cost, like in terms of performance, but in terms of like one's model of reality, I obviously I'm using Zettelkasten, which is an atomic method of taking notes, and likewise I prefer atomic abstractions, one that builds off of things as opposed to applying some different mental model that isn't representative of the underlying parts. Um, because like it's useful to think of things as classes with that own their methods and stuff, but even then, like how much like Java is just like a clear example of what happens when you get too deep into like this idea of like, hey, I have my private methods, my public methods, private variables, and like I have these classes driving other classes, like the methods because interfaces, or like for methods of classes, but then they're also tied to data, and it's like, what the hell? Like methods aren't even in classes. Like they're not even part of the data in the first place. Like so, the fact that we're like creating these interfaces, which like are just methods for classes, which like are like structure like structure meant to contain data, but like we're kind of treating it like we're and like even with like public getters and private setters, like we're kind of treating we're treating our structs as method oriented, function oriented, as opposed to data oriented, which is a bit strange. And I don't mean functional programming, that's different. That supports the data oriented model where you just apply functions to data as for input to output, as opposed to like having objects contain functions that can mutate themselves. Like it's just a bit strange. It's a bit strange. Um, yeah. So like the fact that this was apparently popular according to Bjarne, and then now we're like going back the complete opposite direction is very interesting. Virtual functions were so cool that many argue that every function should be virtual. What? It's like extremes here. Public data was so old school that many argued that all data members should be protected. Yeah, I mean, like I've seen modern forum posts where people talk about just using get like just defining getters and setters for everything, regardless, because they might want to change the interface later. Like, fair enough, but like, goddamn, like that is just a bit. It's too much. Garbage collectors were deemed essential. They weren't. That's crazy. That's shocking. Um, yeah, what the hell? just. Oh my god, please, bro. Okay, this app is a bit kooky. I can't lie. I suspect that a committee with the composition of today's committee would have followed these fashions. Whoa, really? Damn. Wait, when was this? Sorry, 2019. Okay, so this is like 6 years ago. I said 4 years ago. Oh my god, I'm cooked. Today we have different fashions, but it is still difficult to determine what's long-term useful and what's just fashion. It is easy to get swept up in what is currently fashionable, which problems are worthwhile solving, and how are both subject to fashions. I'm not arguing that we should slow down or speed up decisions. For example, I think we were far too slow for concepts and far too fast for this operator, which I've never. By the way, I've never seen this operator before. Before there we go. Before like 2 days ago. So like that is crazy. Um, yeah, slow for concepts is interesting because I know that Bjarne wanted to add concepts. Yeah, so if I remember correctly, Bjarne want Bjarne wanted to add concepts or a concept like model from C++'s conception. Now, I don't remember if this is true. I think that's right though, or maybe it was like compile time embedding. I can't remember which one it was, but I think it was this. I think it was this because I've only watched a talk by him on concepts, and then and then another one on pattern matching, and I don't think he had pattern matching in mind that far back, but surely he did for concepts then. I don't know. What is his operator, by the way? Like um, C++, Google's going to just shaft me. Never mind. It actually worked. The expression returns an object that compares what? C++20. C++20. What? Um, well, he said thank you, but this was 2 years ago. So interesting that because Bjarne wrote his thing in 2019. Oh my god, this guy uses C++98. Uh, there's a new three-way comparison operator. The expression A to B returns an object that compares less than 0 if A less than B, more than 0 if A more than B, and then equals 0 if A and B are equivalent. To write all comparisons for your type, just write this, and it does all comparisons. Oh yeah, no, I remember. So like, there's an ordering type, and it will tell you if it's greater than, less than, or equal to, which is interesting. I don't know if it's how it's useful though. I mean, I guess like if you specifically have a situation where you just want to check if it's greater or less than or greater or equal to, as opposed to like an if thing, then that can be useful. Um, okay. Yeah, it was Herb Sutter's proposal. For those who don't know, Herb Sutter is the same guy who well, he's also proposed some form of pattern matching that Bjorn likes. Um, okay, so strong ordering. This is a partial ordering. Okay, that's quite useful. Okay, it is a comparison method. Additionally, it just works and writes or deletes the six other operator comparison overload operators. That's cool. I'll take one function over six boilerplates. Interesting. So is it not even necessarily that you would use the operator, but more that it's useful for overloading? Yeah, these are automatically defined for us. Okay, that's cool. So, and then, like I said, I wonder what Bjorn's beef with it is. We said far too fast for this. Oh, so annoying. Okay, why? Uh, from browsing briefly online, it would appear that people generally like it. Also, this was 2019, but the feature came out 2020 or like it came out in C++ 20. So maybe it got improvements over time, and that's why he now and that, like that's why he said this. I don't know. I'm very curious. I suggest we could be more systematic, careful, and consistent in our reasoning. So it is easier to point to problems than to suggest remedies. There is no magic source for design that we could bottle. Also, language design for real-world use is not a simple, predictable process. We never have complete agreement about what exactly what the problem is, which problems need addressing, nor which of many remedies is best. Yeah, I'm like, just addressing the problem in the first place is really difficult. We should, however, try to learn from what worked well in the past and what caused lingering problems needing patch upon patch. Different proposals require different kinds and different amounts of work. Yeah. I suggest we should look more at use patterns and interfaces, at least initially, and less on implementation details. Yeah. I mean, I agree, but I don't know where he's going with this. Implementations tend to improve over years and decades, provided the user interfaces and models of use are clean. We need to focus on what and why more than how. Okay. Yeah. Yeah. I agree. And like, if I agree, do I make a note on this? Like, it is my own thoughts. I'm just seeing an agreement, and it's not evidence either. So I guess for this case, because like if I already had this thought, but just haven't made, haven't made a note on it yet, do I cite this as a reference, or do I just say that I agree with it? I guess I'll just be specific and say I just say it as it is, which is that I already had this. I already had this idea, but this voiced it in a way that I um, find clear and agreeable. Okay, more on stable interfaces than on optimal performance, given current techniques. A standard differs for most products by requiring stability over decades. I have the impression that we have been focusing too much on detailed controls lately, on getting programmers to be very specific on how, thus making it harder to evolve use patterns and improve implementations. That is a brilliant argument. Um, Tend to improve over years, provided these variants are exceed. Yeah. Uh, yeah. Okay. Sorry. I guess I don't know what just happened, but I switched to browse mode. I don't know if that was subconscious or if something glitched. I agree massively with this, and I'm and um and it's cool. Not cool. What's the word? It's like reassuring to see Bjarne agree. Yo, like Bjorn's based because he agrees with me. You know what I'm saying? You know what I'm saying? We need to focus on what and why, what and how, more on stable interfaces than on optimal performance. Yeah. Um. Yeah. Pressing one, I swear, is putting me in browse mode. How's that happening? Okay, I'm very confused. Yeah, yeah. So like, I would say it's better to okay, like agreed. First of all, I would say it's better to design first, optimize later. This is also just general programming advice. that has gotten quite popular. But also, of course, applies to systems in general, at least for ones looking to stand the test of time. You know, 'cause, like you can create like a temporary system that just works for the time being, but if you want it to actually be like something that people, oh, if I just press 1 twice, it switches to browse mode, so I can like flip between those two. That's cool. That's actually great. And it's weird how that was intuitive as well. Like I just learned that without even thinking about it. Sorry. Yeah. Like obviously, sometimes you need systems that just are are just implemented for like a thing that would be like we just need this to be done now. Let's just let's get the system. We don't care about future proofing it. Let's just do this. You know. But then obviously if like things that are more, I keep saying obviously, for things that are more long term focused, like a programming language, right? Um, that kind of urgency, although like certain environments may need it, if you are looking to create a programming language that stands the test of time, you can fall behind initially, but then catch up later, and then overtake the other languages because the other ones kind of fell apart. And I feel like that's what C++. I mean, like C++ doesn't always do this perfectly, obviously, because I mean, look at it, but it certainly has that that aura of like the kind of guy who people always say, "Oh yeah, C++ is getting replaced. You know, this language fits our needs now." But in C++, you know, it's slow, but over time it persists. Not because you know everyone relies on it or whatever, or like it's just simple enough that it persists. No, like it persists because by the time it gets to actually implementing the features that other languages do, um, it's done it in a more patient, thought out way, taking you know the experience of those other languages into account as well to improve those features and implement it in an even better way. Um, Now C++ will reach limits in this because eventually, you know, like such basic things such as like having const by default, for instance, like that's a thing, a feature that the vast majority of C++ programmers would agree would just be a good feature. And like at this point, we just can't really implement it. Um, but there are other features like pattern matching, um, or like I don't know, like Rust has popularized the idea of traits as opposed to classes, and I think these are great ideas. And also, Rust is setting itself up for success by having an addition system. That's also really important because it means that it can like kind of rewrite its system, which is like kind of a separate topic, but still, I mean, obviously related. But like the main focus here is languages that can't just rewrite themselves from scratch, and need to keep their past like weight on them. So like Java was like meant to be this big C++ killer, and you know, I mean, to be fair, it did get adopted in a lot of companies, and Java is, well, I don't know if it still is, but at one point, it was definitely used more than C++ was. Um, but now look at Java. You know, like it's genuinely one of those languages that people look at and go like, Java, okay. I mean, you still get like Java programmers, obviously, but um, it's kind of like JavaScript is laughing stock for how just messed up it is, and like, but you know, I mean, TypeScript has kind of come in to be JavaScript's replacement, and likewise, Kotlin is now replacing Java. So like, not to say that like making these languages quickly, you know, with like these cool features, you know, let's just put them in and like solve these problems. Like that's not bad per se, but just know that that language will not survive. And if you want to continue from that language, you need to either create a new one, Kotlin or TypeScript, or you have a system that allows you to keep the same language identity, but change it up um, through like backwards compatibility breaking ways. So like, I mean, an older example would be Python. The shift from Python to Python 2 and the shift from Python 2 to Python 3, right? Those were breaking changes. Or for Rust, you have the addition system, right? Which, I mean, I don't know to what extent the Rust team are comfortable with changing features. I don't know how like extreme they would go. Like if they found out that traits, for instance, which is fundamentally flawed, like I don't know if they would rewrite the whole system to just change it completely and like update that as an addition. I doubt that. But either way, it still allows them to like a bit, helps them a bit. Um, yeah, I don't know. Like right now, there's no language that's willing to just rewrite itself to well Lisp, but like to like rewrite itself to fix issues that it comes across from being too reckless. But there's also something deeper to say about that in general, which is that I mean, from what I believe, which is that we don't need to have the same languages all the time or like forevermore. Like we really trap ourselves in this dependencies of tooling, right? Why? I mean, the why is not too hard to figure out, but we should really build like this culture among the tech industry of resilience, where we just create where we're less afraid to try different things, right? If our language becomes, like it's just fundamentally flawed, and like, you know what, we need to like just completely just rewrite this feature, or and then some other things, like just be more open to like literally creating new languages. Have that C plus 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 as opposed to just being stuck on a language that has lots of dead weight. And that's why I'm glad to see projects like again TypeScript for JavaScript, Kotlin for Java. Some would say Rust for C++, but that's not true. Rust is a different language in its own right, and not like the committee. I mean, like I'm sure they support each other, but like they well to an extent, but they don't um like they're not like directly related, right? Um, like Rust isn't the C++ replacement. It's the systems programming. Um, or like even beyond that, like just the general programming replacement. Like likewise, like Zig isn't necessarily a C replacement. More that it wants to fit into that space that C has dominated and like offer a new way to handle it. Whereas Kotlin and TypeScript are more like just improvements of their previous languages. I mean, Kotlin I'm not so sure about, although that's what I've heard. TypeScript I've actually used, and I mean it's clear, right? Like TypeScript could make like in well, I mean again like with JavaScript, the issue is that the web relies on JavaScript. So you can't replace that backend, that dependency. Um, but yeah, it's interesting, man. Like like should I put that in my notes? Because I just yapped about that, and now like I guess I'll rewatch this video and make notes on that. Um, interesting. This is difficult. Note taking is difficult because I like talking, but then like writing it down is hard. So maybe that's also why I'm making these videos so that if I do come back to them later, which I should, then I can extract those thoughts again and like make them more concrete. Like this is my these words out my mouth are my fleeting notes. Right. A standard differs from most products by requiring stability over decades. I am of the impression that we have been focusing too much on detailed controls lately. Yeah. Yes, the choice between detailed control and higher level, more general interfaces is a design issue, rather than a decision process issue. But choosing the more general interfaces allows implementation discussions to settle on an open set of alternatives rather than pinning down every detail, thus simplifying standardization. Yeah. Um, Design issue. I don't understand this. A design issue is a decision process issue, isn't it? Unless he means like a specific terminology there, like decision process. No, that's just the decision making process, right? Biases, overloads, or poor methods. Yeah, I disagree here. Like a design issue is a design process issue. Like it's a type of decision making or decision processing issue because that's what design is. It's decisions for design. Do I make a note on that? Might as well. Um, are design issues not a kind of decision process issue? Okay. No language feature or library exists in isolation. Um, feature interaction is among the hardest of problems, and often underestimated both as a problem and as something useful. You should always consider interactions with other language features and standard library components. That's hard, especially for other features that are still under development. This is one reason that after a major improvement of C++, we invariably need to do some minor cleanup and addition of minor supporting features. We simply can't anticipate all that we will learn from deployment at scale. We should try not to elaborate features to try to anticipate every possible need. First, we can't. Second, if we try, we generate bloats that we have to live with forever. In quotes. Um, cleanup and addition. Minor cleanup is interesting. Major improvement. That's interesting. Is Bjarne advocating that C++ is in need of a major improvement? Is Bjarne indicating that he thinks C++? Okay, is Bjarne projecting? Well, whatever. That he thinks C++ is in a critical state. Not critical state, but like is in need of major improvement. Usually, I mean, like I say this, I mean, like obviously this, I mean, it seems kind of obvious by the words that he's used, right? But because I said because usually when I see people talk about C++, they say that it doesn't need improvement because like yeah, it's like usually the consensus I get from others is that C++ doesn't need improvement, but maybe these are the people stuck in their ways. I mean, like in the C++ Discord server, there are definitely people who are quite like who do agree that C++ needs some major improvements. To the point where like they'll say, yeah, just use Rust. Honestly, just use Rust. Um, I don't know. I mean, I'm still learning Rust myself, and maybe Rust is like really good. Although one issue I've had with Rust, for example, is the trait system and how it's like in packages. The orphan rule. That's right. The orphan rule, like whatever it's called. I'm not going to explain it in detail, but basically, it can be solved easily by just having namespaces for traits, and also even more easily solved by just removing member functions from structs and instead having. I mean, I know that dot notation is syntactic sugar. Oh my god, hold up. But I feel conflicted about it right now. Um, yeah, and yeah, sorry. Just for example, the orphan rule in Rust is annoying. And I feel like we could do better. It's like Rust isn't perfect either. And there are some ways in which C++ and Rust differ fundamentally. A lot of which are in Rust's favor, like default constants, for instance. But also some are in C++'s favor, like not having to use unsafe. Like obviously that's not great for safe if you like want to like be sure that things are safe. Um, but it also means that in C++ you have more flexibility. You don't have to worry about putting a safe everywhere in your code. You can just make it work if you know what you're doing. Like that's one use case in which C++ genuinely is seen as better. Um, or another one is like with reflection coming up and concepts. They're quite different from how Rust approaches reflection and concepts. Like for Rust, it kind of depends on its macro system for reflection. Whereas C++ is going to add it more like Zig style um, part of the language itself, and likewise um, with concepts. I mean, they're not like Rust traits, but they do seem more powerful in some ways than Rust traits. Because they can be combined with template metaprogramming and yeah, I don't know, just stuff like that is interesting. We simply can't. Yeah, okay. The committee process, designed by committee, or more accurately, designed by a federation of committees, in general tends to converge on designs that encompass the unions of all stated needs. For initial acceptance of a feature, that's bad. It's bloat. Not all stated needs are real and important for the majority of C++ programmers. We need to start out a feature minimal and then grow it based on feedback. Minimal should focus on what's fundamental, clean, and essential. Think of the original Unix and how it compares to modern derivatives. The growth from the initial nucleus of a feature to a full-blown facility should be generalization and integration with other languages and library facilities. Sorry, with other language and library facilities. It should not be endless patches upon patches adding special cases. When such patching with special cases happens, it is a sign that the initial design was flawed. For example, I worry about last-minute quote-unquote improvements. So, can you change the color here? Okay. So the big idea here is rather than prefer to start. Okay, well, assuming you start specialized for both cases, prefer prefer to expand through generalization rather than exceptionization. Creating what the hell? Rather than creating um, special cases, like creating special exceptions, or like rather than through the addition of exceptions. I don't like saying exceptions because it sounds like the feature, the programming error propagating feature. So fine, special cases. For example, standard vector added a special case for yeah. So like classic example, standard vector bool using bits. Like that just creates issues. Whereas the better thing to do would have been to create a bit vector class, probably. Um, yeah, and then bit vector would just be a bool, obviously, but rather than like trying to make a special case, because like if special cases just don't work well with it with an interface, especially when it comes to generic programming. Like if you have a class that accepts different types, doing special cases is just nightmarish. And like again, like generic programming isn't just for types. Um, it can be for like other generic like types of generalization or generic genericity. Um, yeah. So that's a really good thought. I like this. I'm seeing the potential in my Zettelkasten right now. Right. But sorry, there was actually something else from here. Yeah, no language feature exists in isolation. So the reason this kind of made me interested is that, from what I understand, Haskell is a language that actually was built with features in isolation. Um, I mean, it was invented to test lazy evaluation, but like if you look at Haskell, sorry, or even Rust, because Rust adopts the same thing, well, a similar mentality. They're kind of built. They're a lot more atomic, which makes sense because they're inspired by like math and stuff. Um, because you have two ways of approaching a language, right? Initially, and let me highlight this. Um, in C++, this is the case, but the same is not necessarily true of languages like Haskell and Rust, which appear to be a lot more atomic. So yeah, when you create a new language, there are two paths you can go down. And when I say create, I mean like from scratch, like not bootstrapping, not like building off and like I'm gonna make a C style language. No, like I mean like from scratch. Like you want to sit down and just make the best language ever from scratch. Um, you have two options really. The first one is to go atomic, and I don't know if any language does this. Like maybe Lisp does it, but even then I'm not entirely sure. And like atomic is in like you have a language that's basically built up from a simple idea. So like it could be like assembly, like a macro assembler, for instance, might be atomic, maybe, or like just like assembly in general. Like obviously that's like as atomic you can go, computer architecture wise, and it'd be interesting to see a language that like lets you build abstraction from those atoms, which I guess is like what C kind of does, but not really. Um, or like you could be it could be a mental atom, like for Haskell, the idea of functions as first class citizens, and then like even and then like from that you can derive variables which are just which are just no argument functions. And because of this, that because they're defined as functions, they are of course not like you can't assign to them because they're functions, right? So they're non-assignable. You can only redefine them separately, which is what sorry, which is what Haskell allows, Rust allows. But then from those limitations, you can derive new features. Like for like in OCaml, you have the ref keyword, and Haskell offers some similar functionality. I'm actually not entirely sure how it implements that specifically, but from my understanding, it is part of the language. Like it's derived from language features as opposed to language defined, which is the second option for creating a new language, which is having just having like an idea for like a system, and then like creating a new idea each time you want to have a new system. So let me rephrase that. The first option, well, the first option, which is what most things go for, is to just I have these ways of doing these different things. Let me just make those, and then like kind of like have them work together. Like okay, for data, I want to use structs. For variables, we'll just have a variable. like a mutable thing, like an address. For functions, it's like this abstraction. Okay, so like you can like call it to run instructions, and like so like really it's like a coroutine or like a subroutine, whatever. Or you have like the second option, which is more atomic, like in Haskell. For example, the error message, the error types may be an either. Those were derived from just having some types. Like they weren't created as like a special separate feature, like say Zig has, right? Zig makes them part of the core language. In Haskell, they're derived from the atoms of some types. Um, or monads, right? Monads allow you to have procedural quote unquote programming in the language, and then do notation is syntactic sugar, but it's not a different system. It's the same system. It's just syntactic sugar for that system. The actual underlying mechanics are the same, and they are derived from these atomic operations of monadic binding, right? That's so I find that really interesting, and I think that should be explored more, as opposed to just like creating a language. Like if you're gonna create a language that like you generally want to be interesting, try and going for like this atomic approach of I'm gonna start here and see what I can get from it. Like I'm gonna start at functions and then realize that I can have currying, that I can have lazy evaluation, that I can have variables as functions, which are therefore immutable, because they're just single argument functions, and therefore I can even add arguments to these functions, and then I can have anonymous functions. Like just do that, as opposed to having feature from this language, feature from this language, feature from this language. I'm gonna combine them. I'm gonna combine them. Like I feel like Zig, for instance. I mean, I haven't used Zig, but I would suspect that. I mean, Zig tries to be atomic, really. But having you just like pass types by argument as opposed to like a special template system. Um, Zig does have macros. Like it wants things to be in the language itself. But then there are some decisions that Zig makes where certain language features aren't atomic, and they're actually just language defined. And like obviously, like you can argue that things are atomic anyway, because like at the end of the day, they're implemented via machine code. So like in some sense, like they are built up from things. But like I'm talking about mental models. Um, like the mental model of Haskell do notation is ultimately monadic chaining. And it's limited by that. There's no like special exceptions that do notation adds. Like it is just a wrapper for monadic binding or chaining, and you can write it without the do notation, which is what I tried to do at some point, but I stopped because I was like, yeah, this is like at this point I understand the model enough that I will just use the syntactic sugar. But like, I mean, that being said, like I'm not a fan of do notation. I'm actually for like OCaml, for instance. OCaml just kind of has it working without having to have some separate do notation. Like the semicolon is an operator, like it is a genuine operator, or you can use like the let star syntax. Like I find that a lot cooler because it feels more explicit. Um, but anyway, that's a very interesting discussion in of itself. Uh, C++. I mean, even then though, like atoms can exist in isolation, but like the main point here is like atoms. Okay, so like that being said, atoms can exist in isolation, but to derive something bigger, like a language, then they obviously do not. But my point is that they should be that it's interesting and potentially more robust if they are able to exist in isolation. Because then, like, no, because like the cool thing about atoms, right? Like, if you create a system where like things are like designed to be like to link together with another system, and by link I mean like they're part they're part of the same system, like they're literally not just connected, but like binded together by concept. Then that can be useful, but the bigger that is, first of all, the more likely there is to have like flaws. And then if you have atoms that are separate, you can combine them. But the cool thing about atoms, right? Um, like oxygen, right? Like literal atoms in our universe. You know, a bit of chemistry here. Oxygen, O2, you breathe it. Okay. How about oxygen in water? Okay, we have H2O. So now we've taken oxygen, we've created water. Okay, how about carbon? Okay, so carbon is used in like lots of different things. It's used in like, I mean, like organic chemistry. Like we are made of, I think, mostly carbon, for instance. But you can also use carbon, take oxygen, take carbon, put them together. What you get? Carbon dioxide. You get something new. But the point is that oxygen isn't like just bound to carbon dioxide. Like you don't just have carbon dioxide and now like we can't have other things. No, we have oxygen, and you can combine it with this, or you can combine it with this, and then you get different things. Um, Now, of course, like total control isn't necessarily a good thing. Like in Lisp, it's very easy to just get lost in your own method and like what you derive from those atoms. Like they're valid, but like they might not be the best things. So like I don't blame languages for of course wanting to lock down certain features and say, okay, we have seen how these atoms work together. We're going to fuse them and make them inseparable in our language because we think that this is the way to go. Um, and I think that's okay to like limit which atoms can be like which like configurations of atoms are allowed. But I would never fuse the features implementation wise. Um, and I would and I would never and I would think that it is unsustainable or that it is bad design to okay. So even if a language chooses to restrict the configurations, the allowed configurations of atoms, I suspect that, or I theorize that it is um, bad. That it is bad, yeah, bad design to fuse these atoms in implementation. Rather, even if the interface is fixed, the ability to the ability for the language to create new interfaces or modify existing ones at the implementation level should be kept atomic. So that's like a summary of my thoughts. Um, wow, wow, oh my god. I mean, like I do expect to have a lot of thoughts about things like these because these are thoughts that have been in my head for a long time, and I've just started my Zettelkasten, so it's only natural that I already have a lot to talk about. But cool, I am loving this so far. This is really just better than just reading and like not doing anything about it. I must say. Um, yeah, that's what I wanted to say. The other thing is forever in like quotation marks. My only question there is why quotation marks? Because like when is it not forever? Like on a larger scale, not just like we have deprecated trigraphs, but I mean like bloat that genuinely is plaguing C++ right now. Like, is he implying that that bloat could one day disappear? Um, is there bloat in C++ right now that could one day disappear? Or is it possible? Could there? Could could he be thinking that the bloat in C++ right now is not as forever or unfixable as we may currently think? Or is he just or is he more so just pointing to the fact that C++ obviously has a finite lifespan like anything in this universe? Uh, I wonder. There are two fundamental ways of approaching the unavoidable uncertainty in design. Add improvements until everybody feels well served, or cut until there's nothing left to cut, and all there is principled and fundamental. Um, what? How do these? How is the second one an approach? Like I feel like this is just removing. Okay. After both approaches, experience will show the need for changes pre-release, and additions. All you can do post-release. I clearly favor the second approach and consider it proper engineering based on principles and feedback. I consider the former hacking and politics. Okay. I mean, I agree that this isn't good, but like what? Like okay, so like, but like, how do we get features? Then I wonder because he said about generalization in a standards process, compromises are necessary, but we must try to ensure that compromises are not between irreconcilables or just union of features bloat. What? We must try to ensure that compromises are not between union of features. Yeah, like okay. Interestingly, when he says union of features, that's what I mean by combining features, like merging them. Um, is it though? Actually, I don't know if it is. I don't even know if he's saying that at all. What the hell even is this? Ideas, differences of people that are so opposed or inconsistent that they cannot be reconciled, compromised, or brought into harmony. Interesting. Um, do I highlight this as well? Vocabulary. Um, pressing one. What? To see back to text selection. This is this this means ideas which are so different and incompatible that they cannot be conciled or like or compromised. Yeah, compromised. And then union of features. I mean, that could, yeah, I don't know. When considering a problem, we should. I mean, I guess I'll leave a question for that. That's kind of the point of these notes. Um, what does this mean? When considering a problem, we should always try to articulate who benefits, how do they benefit, how significant are the benefits. For example, CT Bello. Also, who might suffer new problems. Be specific and concrete. Average users can't is neither. The benefits of a proposal are never obvious or self-evident to everyone. It is the task of the proposer to provide initial answers. Note that every proposal carries costs, committee time, implementation, documentation, teaching, dealing with older implementations, and documentation, and more. Yep. It is a task of the proposer to provide initial answers. The benefits are never obvious or self-evident to everyone. Oh, okay, I see what it means. So, like, although the benefits may seem obvious to you or a certain community, other people may not see the benefits so much. Is there an example of that? Like, some people did not see the benefits of the ordering operator that we just saw, whereas others may clearly do see the benefits, right? That's a cool statement. Like that's like low key a good note title, but it's also like so obvious. I don't even know if I need to point it out. Okay, yeah. I don't have much to say about it. It's just true. But okay, like what's interesting is that he asserts responsibility on the person who gives the proposal to explain why it's useful, which is a bit more debatable. Hmm. Um, yeah. Uh, oh my back. Jesus Christ. He, she, they who make the proposal. Okay, I'm actually going to unhighlight that because, like, yeah, I don't know. I mean, like, it definitely applies to C++, plus plus. Like in this specific scenario where the committee is busy. Um, but like generally speaking, yeah, I don't know. That's not so insightful. Setting goals is usually far harder than the detailed design and implementation of features. Harder. We are good technicians. I always wonder if if Bjorn uses Zettelkasten because like a lot of his writing, like his writing style, is full of assertive statements, right? Like he says, setting goals is usually far harder than the detailed design and implementation of features. Like this sounds like it's a Zettelkasten note because like it's a declarative statement as opposed to other writing styles I've seen where they're more like explaining, less asserting, or like describing, less asserting. But like Bjarne is like putting forth these ideas as statements. Which I mean, yeah, I mean, like it's definitely just a writing style as well. But I feel like as Zettelkasten would get you would also push you towards this style, which is interesting. We are good technicians and we have theory and existing practice to guide us with the necessary work once goals have been established. Unfortunately, we are not good at agreeing on goals and articulating them. Articulating them is also important, yes. Often we end up in a mess of requirements. Language design is not product development. We don't have a high management setting fundamental priorities for us. Few of us have workplace experience for that, if for no other reason than that our firms are each in a specific business. I think product development and analogies have been seriously overdone over the last few years. Interesting. I can't think of any examples off the top of my head, but um, yeah, highlights the importance of a starting point. Um, More specifically, one which one which is clear to everyone working on a everyone in a collaborative project. There we go. Um, we are not good at agreeing on goals and articulating them. Why are we not good at agreeing on goals? I'd say we're not good at agreeing on goals because we're not good at articulating them, or even like articulating why we don't agree on them. also add that we are not good at articulating why we agree, we dis or agree on goals. Is that true though? I mean, maybe by we, I mean, I assume he's specifically referring to the standard committee. Um, I don't, I don't know the committee, which actually, in that case, it does make sense as well that he's written this paper. Yeah, like this paper, and like as part of the ISO collection, as opposed to just like a blog post, because clearly it's aimed towards the committee. This is a proposal in of itself, which is quite cool. Um, but like generally speaking, people can kind of resonate with a goal or feel that a goal doesn't quite like make sense to them, but they're not really good at articulating why. So I'd also add that generally speaking, we would benefit from having more pressure or space. Like not like you must do this, but like having more freedom kind of thing. Or like I don't know, like incentive or like drive, but like expectation even to articulate why why certain goals resonate with us or rub us the wrong way, to use idiomatic language. Okay. Neither arguments nor data are by themselves conclusive. Neither arguments nor data are by themselves conclusive. We are far too good at fooling ourselves with clever arguments, and data always require interpretation. Yeah. Um, or rather, we cannot assume that our own interpretation is objective. Because like obviously no one just like looks at numbers and says, "Yep, those are numbers." Like like they interpret it before they like you have to interpret data before you can say anything about it or like apply it to any arguments. Um, but the danger is seeing data and thinking that how you see it is how other people will see it, or how you see it is like objectively the only way that that data can be interpreted. It could be that there are other things you're missing, and I personally find this a lot. It's why it's why I really struggle myself to make assertive claims, because I will see something and then like as like I'm writing an argument, I just stop and think like, yeah, but it could also be this, and it could be this, and it could be this, and then it becomes like a case of just honestly I don't know, and we and the solution to that is more data. Um, because the more data you have, right? Furthermore, the more data we have, the more we can determine which interpretations um, line up, yeah, like stand the test of generalization, I guess. That's not well worded, but the idea should get across from that. Um, or maybe I'm not considering how my notes can be interpreted, which is another thing as well. Like your own words can be interpreted in different ways, which is really just unhelpful. I think that's an English problem as well. And humans, man, humans would actually quite benefit from a reform in language. But just like it's so sad. It's so sad that Esperanto was shut down. And I believe that there were governments as well. There were state efforts to like try and like beat down Esperanto, which is so sad because like that was like a real effort to have a language that I mean, okay, I mean, like I think Esperanto's goal was more just to have a language that across Europe that people could use. But I would love to see like actual efforts among bigger communities to invent ways of communicating that are more robust, not just like more accessible. Although that's good as well, but like genuinely, you can express yourself better than natural human language allows. Because like we design tools, so let's design. So like why are we just giving in to the language that we're born with? Obviously, it's not easy to learn. It's not easy to it's not easy to learn a language. But either way, we should still like that. Doesn't mean that we should just accept the way that we are born and like raised. Like if you said that about anything else, you'd be like, "What? No." Like if I see a way that something can be improved, then obviously I'm going to improve it. Then likewise, why don't you do the same for language? Um, And the answer is that you need to have a big community of people to use the language amongst each other. But it's interesting. It's very interesting. One thing that the academic literature can be quite good at is the interpretation of data from experiments. Our experiences are necessarily narrow and incomplete. See what I mean? How like each uh by like this the style here, each paragraph starts with an assertion. One thing that the academic literature can be quite good at is the interpretation of data from experiments. Um, like V in general, I guess. Yeah, and like it's good to get a variety of interpretations because yeah. I mean it's self evident. We are far too good at filling ourselves with clever arguments. Fooling ourselves. Is it? I mean, okay, like clever in what sense then? Like it seems clever, I guess. Our experiences are necessarily narrow and incomplete. Necessarily narrow and incomplete. Yep. We couldn't possibly take into the accounts of every other. I mean, we could actually, but anyway, the C++ world. I mean, once again, by R, he's talking about the committee. The C++ world is too large and diverse for anyone to know all, and anyway, problems and styles of solutions change over time. It is interesting how he says, like, when he says we and R, he is, I think, referring to the committee specifically, but even so, these do still quite apply to like a general audience. Let me wait, can I just right click this to highlight? No, unfortunately not. So I need to do this. Ay ay ay, bro. Okay. When he says "our" and "we", I assume he's referring to the committee. But it's interesting how a lot of what he says has broad applications to the human design of systems in general. And again, that's why I love programming. It's so applicable to other contexts. Oh my god. Yeah. Your perception, styles and solutions change over time. Yeah, problems are dynamic. Your perception of your company's or industry's needs may not be correct, and even when they are, they may not be conclusive for the whole community. Serving your needs perfectly might even harm the community as a whole. This is true for us all. Harm. How so? Aye, 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 bro. I'm gonna crash out. I'm gonna crash out. I'm gonna crash out. Can I? Man, I need like a better workflow. Like this app is already not. It's not designed for my style of note taking. I just need two colors. I need the colors to automatically make a comment, like open a comment, and I need to just be able to just drag to like just to like track my eyes. Um, this one, problems and styles of switch over time. That's really good. insight. Like I pressed key highlights. I swear I did. Yep, this is true. This is generally true. Problems are dynamic, and we cannot expect one single solution to stand the test of time and work for every future problem slash situation. Yeah. Yep. I mean, not to get political, but like, obviously, a classic idea is religion, right? Religion is static. It's a genuine solution to like how you should live your life, honestly, because like it is a philosophy as well at the end of the day, not just like a purpose, but like a genuine way, like a model for you to live your life. But because it's static and it's um unchanging, I mean, not obviously. I mean, some religions can change, but I mean, like for the ones who like to believe that the way of life has been given by God, and that like it should never change, and like we should live like this the whole time. Just that idea is very flawed in practice because it means that people like these solutions to how you should live your life don't necessarily apply to new ways of thinking or to new lifestyles. I mean, not lifestyles, but like new needs, I guess. Because like if you're a farmer in like the 1200s, obviously your needs and like your problems are different from someone who's like an office worker in 2026 or a paramedic. Like it's it's just not the same. And it just doesn't apply much. Like a good like if a a religion that I would see as genuinely useful, like not just good, because like religion in of itself is a type of certainty that I'm not comfortable with, but the but like for it to be useful for like on a practical societal level, um, I feel like it needs to be dynamic and like the values. Like okay, like the values don't need to change. That I agree with, but like the ways it outlines how you should solve certain problems needs to change because the problems change. Like they're just not the same problem. Many perfect languages have failed. Many perfect everything's have failed. If we are not careful, C++ can still fail. Okay, so earlier I said after a major improvement of C++. So it seems like there is actually a sense of imperative imperativity. What the hell? A sense of urgency because C++ can fail. Okay. Why am I highlighting it? I'm not. Okay. C++, yeah. So there is a sense of urgency. We still need to be flexible and responsible. That is, our designs need to be such that they will still be relevant when the world changes, not if the world changes. Nice. We need to understand that every design is a risk because we can never be 100%. Okay, actually, no, this is a really good keynote. Sorry. This is a really important mindset to adopt. It appears obvious, but a lot of the time we do in fact think of change as possibility rather than necessity. I don't like this necessity. Like it doesn't need to happen, but like it just is bound to happen rather than guaranteed. Because it is guaranteed. We need to understand that every design is a risk because we can be 100% certain. We can never be 100% certain that what we have correctly addressed important that we have correctly addressed important problems and don't block future improvements. Yeah, we cannot block future improvements. Oh my god. However, that mustn't paralyze us. Okay, doing nothing also has consequences. We cannot avoid taking risks. Let's make sure they are deliberate and considered risks. Okay, this connects. We cannot make progress, like this paragraph connects. We cannot make progress if we insist on perfection. And that's an issue that many perfectionists, myself included, have struggled with. We need to move cautiously forward, basing initial designs on what has been seen to work and expect to have to elaborate later. This can be done only if we have a reasonably clear idea of where we want to go. Yeah, which is also hard, by the way. Like having a clear goal, as he says earlier in the text. So, as also mentioned earlier in the text. Okay, but as yeah, also because yeah, in the text, um, having clear goals is also is difficult. Is difficult. Not yeah, but not impossible. Okay. In the absence of a view of a general direction, extension becomes more mere hacking, and we are doomed to apply patch after patch. A large working system is always a result of work on a smaller working system. Actually, that's why I really struggle with bug fixing. Sometimes because I find that I am just patching bugs as opposed to like addressing a genuine flaw in my system, which is probably why I haven't like completed many applications because I find bugs and then these bugs just expose inconsistencies in my own model of how I well yeah like in how I model my code. So a but like I I think it's good that I don't just continue because instead I refactor. And like this refactoring process, I mean, for me as a learner, obviously, refactoring is then really good because then I can see, okay, I got bugs here. I'm gonna kind of like roll back and like kind of like just kind of rethink my model and like why did I get these bugs in the first place? Because it's not just like I forgot a semicolon. Like it's because my approach is just generally flawed, and that's really good for like self improvement as a programmer. But obviously in production code not so much, because then you can't just refactor willy nilly. Um, and that's why, like, I want to modify this software, for instance, to better fit my needs. But I just have a feeling. I mean, I don't know until I try, and I should try, and I think I will try to try. But definitely, I fear that this software here, this app, Ocular, is going to be set up. Is not going to be set up in a very modular way. But I would love to be proved wrong because I would love to extend it. Um, A large working system is always a result of work on a smaller working system. So does he agree that there is a level of atomicity? So would he then agree that an atomic approach to system design, i.e., smaller system, or rather a large system comprised of smaller atomic yet still um, connectable. What was the word? Like it's they're atomic, but they can still be used between each other. Not merged, not connected. Interop. Nope. Oh my god. Okay, well, we should find. It's atomic systems. Yeah, whatever. Um, is the way to go. Uh, hmm. We cannot make progress if we insist on perfection. We cannot avoid taking risks. Yeah. So my question is then, how? I mean, obviously, I need to stop saying obviously. I mean, like, I'm using it correctly because, like, I was about to point out that obviously he says this, and like, yeah, like I can see that with my eyes, but like, it's just a filler word at this point. Um, we we cannot avoid taking risks. Yeah, I mean, he says my train of thought. Oh, by the way, it turns out, by the way, my family does actually have. Apparently, ADHD runs in my family, so chances are I also have this attention whatever disorder. Just that it might be a bit more. I might have found a way to kind of make it work to an extent. Um, what? Yeah. So my question was, how do we avoid taking risks then? And as he says here, make sure they are deliberate and considered. But like on a broader scale, I think the bigger question I want to ask is, when do we take risks? So I also wonder not not how we take risks, but when we take risks. But when we choose to take risks. When might it instead genuinely make sense to aim for perfectionism and then move forward when we feel that our system is robust enough? With the, yeah, obviously, and I am using it correctly here. Obviously, we cannot say with any guarantee that a system is truly perfect. But what I mean is that what I mean is that a risk sounds like proceeding even when you are highly uncertain, as opposed to just, ignorant, as we always are. Um, yeah, that's a subtle distinction, but that's what like really gets me stuck sometimes. I mean, that being said, I call myself a perfectionist, but I've definitely dealt with it better over the years. So I do make progress by just not being afraid to try things, and if it fails, then good. I can use that to improve to continue perfecting my thing. But I do struggle still with starting something when I cannot necessarily revise it later. Um, yeah, that might be something worth talking about in a different video. This is great. Like the amount of ideas I'm seeing now just from this note taking. Like I haven't even put them into my Zettelkasten, but like after this, I can surely just copy paste a lot of these into my Zettelkasten. I can't wait. I can't wait, dude. This is amazing. Um, I'm on page 4. How long has it been? See, it's been 2 hours on this one article, but like it just shows we the importance of like actually reading, like actually like taking notes as opposed to just reading passively. This can be done only if you have a clear. Okay, yeah, I do agree with what Bjarne's saying, and I think there's a wider a deeper discussion that needs to be had about the systems that we employ for deciding when risks are worth taking, and when we leave our lab, let's say, of perfectionism to just let it go ahead. Because like in some cases those can be time pressures, Like, okay, we have 2 months to make this as perfect as possible, and then after that, we just have to release it. But it could also be we like have infinite time to plan this out, but at some point we should get it out. So like when is it good enough, right? That's the other time that you release a non-perfect product, let's say. And when I say non-perfect, I mean non-perfect in the sense that it has flaws that you can maybe even identify, but just don't know how to fix them yet. That's what I mean by perfect in this scenario. Because once again, nothing is perfect, right? But like if we define it in like perfect within our own knowledge, then that's a bit more workable. We never have a complexity-free choice in design and improvements. There are billions of lines of code out there, millions of textbooks and popular blogs, and much old knowledge is stored away in millions of heads. And Zettelkasten, plural. Also, existing language features and the type system needs to be respected for new and old facilities to interoperate smoothly, which is where whoopsie, which is where new languages come in. Stability is a feature as well as a serious design constraint. It is, yeah, that's actually a really good. Sorry, that's a great point. Um, I can't read it now. Stability, yeah. Um, people, whether or not a language is stable, is a big decision. Is a massive actually decision factor for programmers. C++ and C++, which maintains C++, which maintains stability, and Zig, which is always breaking it, are great modern case studies, or great not modern like current case studies, or even if they no just in general, because like if we look back on Zig in the future, like let's say Zig gets is version 1.0, like we'll still have that to look back on as a case study. And I saw something else here. Yeah, Zig is once again is a great example of a language that is chasing perfection, um, or at least perfection. And by perfection, I mean it in the attainable sense. The feeling that something is truly as good as you can possibly make it with your current knowledge. Yeah, I do wonder if there's a word for that, but I'll come back to that later. It is always frustrating when old code and old design approaches stand in the way of progress, but people really hate it when their code is broken. Yep, myself included, honestly. So like as much as I will fanfare, creating C++2. Well, I mean that's different, no, because like I hate it when, like when existing code just breaks, because like a system that uses the code for some reason updates it, like updates and then breaks these existing modules. That sucks. But it's definitely possible to create a new like a new language or an update to a language while still maintaining the non-breakage of the existing code. Like again with Rust addition system, you can introduce new versions, but then still compile old versions, and that's fine, right? But of course, then the stability has to be the interoperability of the old code to the new code. Like that interface has to be the Rust interface can't really change. Some breakage is inevitable because much code depends on non-standard features or on features so obscure that they arguably always were bugs. Damn. In the code, in the compilers, or in the standard. Damn. I can summarize most people's attitude. C++ is too complex. We need to make it smaller, simpler, and cleaner. And please add these 2 features. And whatever you do, don't pick my code. Yeah. And, very valid. All of these. I think so too, but of course, it's impossible. See, he said of course. I say of course. Obviously, of course. Even deprecating features has never really worked because users insist on compilers supporting old versions. Yeah, sorry, because I'm thinking this through the what if you just support old versions with and like again like the Rust addition system. Deprecating major features is impossible, and deprecating a minor feature is an annoyance without significant benefits. C++ programs from 20 years ago still run. That's a strong argument for C++ use, partly because it gives hope that the code we write today will run 20 years from now. I really want to know what Bjarne thinks about um, Rust's addition system. Like, I have to know because, like, to me, it just seems like it's not perfect. Because once again, there are still limitations. To the point where eventually, like, you will need a Rust 2.0, and Rust will be replaced someday. But first of all, that's not a bad thing. It just means that we once again evolve and we move to a new thing, and the old code becomes legacy code. And of course, like it can be annoying, and like we have to rewrite our code in this new language. But if the new language offers enough benefits, as Rust does, for companies to want to rewrite their code bases, that's good. And then either way is good because people find now, but we're finding that if you rewrite your old code base in a new language like Rust or Zig, you just find bugs and or like find ways to improve your code anyway. So it's a good habit regardless. Um, but either way, Rust's addition system is still better than having no version control whatsoever. It's much better. Um, yeah, I feel that Rust's addition system, capitalized actually, addition system is as good as a fix to this as we can currently imagine. I can currently imagine. Um, and I wonder what Bjarne thinks about that. Plus, that be also, um, there's something to be said, or like there's an argument to be made that we should embrace new languages as they come. In fact, I think we already are, as people are seeing enough benefit from Rust, from languages like Rust and Zig, that big tech companies, which by the way are like not easy things to wind bend. The words are in my head, but the image is there. The big tech companies will choose to rewrite their code bases. So I'm not even sure if we as a community need to consciously be more open to new languages, since it seems to me that people will naturally jump ship once the ship is sunk enough and the other ship is enough of an improvement. But I do think that we should encourage that we should encourage research into new ways of programming. None of none of this, um, but it doesn't matter anyway because X language will always dominate. That is the sentiment I don't like. I hate, because it's like, are you serious? Why you even? Well, maybe it's insecurity. Like I know this language, I love it, and I don't want to move away from it. So I will look down on other languages that try to improve its features, right? Or like improve the way it works. I think that that's a really just unproductive mentality. I don't like it. Compatibility will always be a sensitive issue. I recommend focusing on coding guidelines and static analysis for achieving simplicity and correctness beyond what the language itself can guarantee. Oh, okay, I see. Guidelines and static analysis. I consider the C++ core guidelines a good, though still incomplete example of that. By the way, I have these bookmarked. They're on GitHub, and I want to have a read through it because I think that'd be really interesting. We can and should write type safe and resource safe C++. Of course, language evolution should support this ideal, um, as documented in D and direction. Applying techniques and new features to ensure type safety and resource safety to large existing code bases is very difficult, but still far more manageable than dealing with seriously incompatible versions of the language. Oh, okay, that is really good. Okay, I feel like it's also obvious, but like there's really good arguments in here. Here, this because like the thing here is languages. You know, language designers can think for years about what makes for decades about what makes a language good and like good ways to encourage certain behavior in a language. Like, okay, we want type safety, so let's have like a type safe system. Let's like make any non-type safety a compiler error. But we are finding now that there are limitations to this. Like if you look at functors, classic like for me, it's a classic example. Functors in Haskell are not functors. They allow functors to be implemented, but they cannot enforce that they are functors. And that right now is just a technical limitation. Maybe one day it will be possible, but for now it definitely isn't possible. Like at least through the language itself, like the compiler itself. So instead, you just say, okay, if you're going to use a functor, use it in a way that complies with our model of a functor. And that's what it does. Even to the point, there's a book that I no longer have because I borrowed it from the library. It was, I think it's called Programming in Haskell, just straight up. Um, and it introduces functors, but like it doesn't even mention that you don't have to follow this model for functor. It just like assumes that if you define a functor, like a Haskell functor, that it complies. And like it tells you like what functor is so that you can comply, but it doesn't even mention the fact that it's not a strict requirement, which I think is interesting. Whereas learn new Haskell for a greater good or whatever it's called, that one does mention it as a note, which is interesting. Yeah, so there are bound to be limitations for what a language, for what a compiler is able to enforce in a language. And that's where consensus on how to use a language properly come in handy. Come in handy, are essential to good programs being written. But it is unrealistic. But even so, we cannot ever expect all programmers across all production software to perfectly follow such guidelines. That being said, LLMs, large language models, are kind of perfectly suited for static analysis, and may be the way forward. And maybe essential. I may become essential to good programming moving forward. Now, I mean, and I say perfectly suited because large language model, and you're writing in a programming language. So like you could think of this like it's like it's as if you wrote a paragraph and you ask an AI to like analyze your paragraph or like your essay on like a certain mark scheme or criteria. It's like that, except it's even easier because in codes the guidelines even like because I mean like anyone who's had like English classes, I'm sure you've had. Well, I mean, everyone has, but like a class where like you write essays for like a humanities subject. I'm sure you've had the experience where you're like you feel like you've been marked unfairly because of some subjective thing at some point, or like maybe the criteria is flawed, and that's another point to be made here. But whatever the case, because of subjectivity and like the guidelines maybe too vague, like you like lost a few marks in this way. Whereas in codes, that's not really as possible because there's less room for such subjectivity with coding guidelines. Because I mean, it's code. Like it's you're not writing an essay with code. You're writing instructions. So those are a bit more easy to analyze. Therefore, an LLM, if it can process human text, like who's to say it can't process code in the same way, really. Um, so that's really cool, and it's why I like as I've been learning OCaml. Um, I mean, not as I've been learning it. I've tried just writing my own code first, but then after I finish writing code, I would often just send it to like Claude or whatever, and then God forbid it steals my code and it puts it into its database. Although to be honest, I don't care. Like whatever. If it improves the tool, fair enough. But I send my code into Claude and I ask it to just give me feedback on conventions and guidelines, and then it says, "Oh yeah, okay." Or for Rust as well, like usually, I've noticed that you use a return statement at the bottom of your function. In the Rust community, it's convention for people to just use expressions. Like an expression with no return and no semicolon. Returns are used for returning early errors, and that's what it told me. I was shocked. I disagreed because I was like, "What? What? Why would you do that? Like that's so unreadable." And I still agree, by the way. But it told me what was convention, and it gave me a static analysis. Could the compiler have told me this? Yes. But there are other examples where not so much, like white spacing or like naming schemes and like stuff like that, where a compiler would struggle to do that without literally embedding an LLM into itself. And maybe compilers will, but for that to happen, we need to have much more small, um, offline, quick to process LLMs, and that's a bit harder. So again, like that's a technical limitation. Um, yeah. We can and should write, yeah. So like with type safe and resource safe C++, like Rust offers better ways to have type safe and memory safe code, but that doesn't mean it's impossible to do it in C++. And there are features in C++ that make it possible. It's just that Rust makes it so much harder to shoot yourself in the foot, as people say, right? But if you understand C++ and like use the good practices and the good guidelines, then it's extremely powerful. If not a bit verbose at times. And like verbosity is a different argument. But like in terms of like actual writing good programs and good software, again, like language syntax aside, um, C++ is capable. Is very much capable. But we do need these guidelines that we follow. Language evolution should support this ideal. Uh, yeah, implementation experience is usually beneficial for improving a design, but implementation work tends to freeze a design so that alternatives and improvements might be ignored. It is generally unwise to implement before the fundamental requirements and principles have been articulated and the key use cases have been chosen. Yeah, write your specifications. Don't just yap it. And the key use cases have been chosen. Um, this reminds me. People in one issue that people highlight between Rust and a language like C++ or C, or not even Rust necessarily, but just like more abstract languages versus less abstract languages, is they're against the idea of abstracting first. They think that it's better to just start writing your code for your use case and then modify it as you go, as opposed to starting with a mental model. Like I think the Primogen, right? He's a big, if not the biggest, programming content creator, influencer on YouTube, whatever. And like he has shared this view many times where he thinks a big issue with Rust or like Java or whatever is that people start at the abstraction layer of what they want their traits to be or their class to be, their interface to be, and then that leads to a system that may not be good on the first try. So then if you want to modify your system later, you need to like completely refactor your entire model, right? But I would argue, first of all, refactoring your entire model is great for learning. Um, and also it is better, as Bjarne says, because it means that you can generalize, like you can still break down your big model of what you want into smaller models, have those, and then have those build up to a bigger model. So first of all, doing that is just more robust because you have these smaller models that can build up. Like if you have an issue in your system, it could be that a small part of that has an issue, and then you just fix that, or it means that you've like kind of arranged the system bad, so then you just rearrange it, and that's like not as problematic. Whereas I think the Primogen's idea and a sentiment that other people share is that you have this big monolithic system that's like abstract, like a Java factory integrated slot mess, and like trying to like refactor that is just impossible. But that doesn't mean you need to like start from the code and then build up to abstraction. I still think you should abstract first, but just be selective about small abstractions as opposed to a big overarching one. Um, and then, as you become more experienced, you will be able to start with bigger abstractions because you already know from experience. Yeah, this fits this problem, so it's fine. Or even if this doesn't fit this problem, I know that this particular abstraction is very flexible and can help me, and like will be fine to refactor. So like that's fine. Um, and I get again like those kind of arguments against it, against abstraction, probably mostly come from production environments where you don't have the time to be able like to afford to do that. Um, but I wouldn't parrot it as like genuine programming advice, to not start with abstraction. I think starting with abstraction is the right way to go. Um, yeah, or like at least if you do implement first, as opposed to not abstracting, know what you're implementing towards. Um, like don't just like start and then pray that things will work out later. Um, and again, like it depends what you're like. If you're doing for learning purposes, if you I mean, like if you're a beginner, you're helpless. Like just go out there and just learn, and like just get your hands dirty. But if you're coming from a more um experience point, then you don't need to worry about like getting stuck in decision hell of perfectionism because you have experience, you know what works. So like just apply a bit of thinking to like to like not like perfection, but to just think ahead a bit. And that thinking ahead includes knowing what abstractions you want to make, and then you can use that to guide your initial to guide how you start. Whereas if you well, sorry, which is why I think a lot of people struggle with Rust as well, is because they're coming to Rust probably not as great programmers, maybe because like maybe they just don't have the experience, um, and then because they don't have these models that they can already apply to Rust, they need to learn these models from scratch or from their own experience. So then, of course, like they can't abstract first because they haven't been taught how to abstract. So they do what they can do, which is to just not abstract and to just try programming. And then, but for some reason, that turns into them thinking that they should never abstract, even as they gain experience into how to abstract properly, which I think is a bit misguided. And by a bit, I mean extremely, because it's very important. um, but like for me, for instance, not to toot my own horn, but like I did have experience. Well, actually, quite a bit of experience trying to abstract libraries in C++. Like build a system in C++, and then realizing that I didn't have the features I wanted to make the system work in C++. And then by chance in university, I learned Haskell, which of course introduced me to functional programming like functors and algebraic data types, stuff like that, which then opened up Rust to me as more approachable, of course, because I already had some ideas from Haskell, and then that's why for me, learning Rust is a lot more enjoyable than someone who's like I don't know learned Java for their entire life and now needs to switch to Rust, or like has learned C++ for their entire life and like now needs to switch to Rust without having ever looked into like Haskell or OCaml. So yeah, I mean wow, that's a lot of words, but I do feel quite strongly about that. And I wonder how I can work that into this. So to freeze a design, it's generally unwise to implement before the fundamental requirements and principles have been articulated. Yeah, I don't even know how to. I kind of went off on a tangent there to the point where I'm not even sure I can make a note about it on this. On this, um, I would say that implementation experience is also good for planning a design in its initial stages. That is, knowing which abstractions will work, or like which abstractions to start with, as opposed to just jumping straight into jumping straight in with no concrete goal, concrete goal, or like or slash method. Because like a like, do people even understand what an abstraction is? An abstraction is a framework. It's like a model you want to aim for, and like to guide your thinking. So if you say I hate abstraction for like like in I mean I see there was extreme examples, but I've generally seen a lot of people say they like I hate abstractions. Like what do you mean you hate abstraction? Like this being a bottle is an abstraction. Like calling this a bottle is an abstraction. But in programming, um, like if you truly avoid abstractions, whether they're zero cost or whatever, then like what are you even doing? Like you can't program without having some kind of framework to go off of. Like a variable is an abstraction of like registers and memory locations. So and assembly is an abstraction on circuitry inside your computer hardware. Like abstractions are not things to avoid. They are necessary for us to think in the first place, by the way. You can't think without abstraction. So why do people look at abstractions and go, yeah, I don't like abstraction. I think it's because they just don't like that particular abstraction. Um and I think those come with bad experiences where you where you, they, whatever, want to follow an abstraction but don't know how to actually implement it. And that's why I say here. Well, first of all, it's why this resonates with me, but also why I say that that experience of implementing it, an abstraction, makes you more confident in your ability to follow it. I mean, like obviously, right? Like if you know how to implement an abstraction, then you will be more inclined to want to use it. Um, or maybe you don't like that abstraction because it doesn't work for this particular thing. But then like I just don't get why people say that they don't like abstraction. Full stop. Like it's not even like it's not even an argument. Like there's no argument for saying abstraction is bad at all. Like that word abstraction should not be used in any context of good or bad. It's necessary. Like it is necessary as a model of thought. You cannot think without abstraction. So to even bring it up at all, like in terms of is it good or bad? No, is a particular abstraction good or bad? We can evaluate it, but like don't fear languages like Rust or functional programming languages because there's too much abstraction. Like what do you mean there's too much abstraction? Like someone could look at C and say, oh, there's too much abstraction in C. If they're used to assembly. Not to mention that we should aim for abstraction, by the way, because it does actually it's psychologically proven to reduce cognitive load. And I did a review on on a language called Mu a while back. I mean, I say a while back, maybe like last week, maybe. Um, and I didn't like it because it was like assembly. I mean, yeah, it was effectively assembly because it wanted to be like a no hidden workflow language, but you can't you can't not hide workflow or what's it called, control flow. You can't not hide control flow. Like it's impossible because you could always go deeper. Well, until you get to like the quarks. But like at that point, like at the quark level, like can you even imagine the scale of like how many quarks are working together? Like you can't have that in, if you can't fit that in your head. Um, that's not to say that over abstraction is impossible, but there are tried and tested cases of like assembly. To say assembly is fine is just false because it adds cognitive overload for very little benefit, and this the little benefits can be argued. Um, and one more one more note for other bad abstractions, they may be bad because they aren't abstractions. Like they aren't abstracting. They may just be someone's mental model of how something works. If but like it's not actually derived from the thing that they're looking at. It's more just like applying a model to something. I don't know if I would call that abstraction. Because like the word abstraction is clearly a verb, right? You are abstracting, making something abstract. It's an abstraction. Like is it like like extraction? You're abstracting from something. Um, so to just like slap on an abstract idea, okay, we could say that, to something that isn't like that doesn't fit. Like it's an abstract model, but I wouldn't call it an abstraction. Um, and that might also be a very important. I mean, sorry. Well, assuming I'm correct, that about the difference between the two meanings of the words abstract idea and abstraction. that could be a really, really, really important insight, and thing to think about. Oh my god. Okay, so where do I even write that? Oh my days. I'm gonna put it in my inbox. Yeah, I should use my inbox at some point. Um, abstraction versus abstraction as a verb. Abstraction as a verbal noun. Sorry, it should be a list. Meaning to abstract from something versus an abstract idea which doesn't necessarily derive from the same source it's being applied to. Abstraction to me, abstraction to me implies, implies creating, deriving an abstract model from the source it is applied to. This may be an important distinction in discussion around abstraction in programming language design and approaches to programming and models of programming in general. Okay. Damn, dude, this article is 7 pages long, and I've spent like 2.5 hours. This is so cool. This is actually so cool. I might be in my honeymoon stage right now of note taking, but it feels so good to have a note taking method that actually leads to productivity. Oh my god. The VASA. Usage experience reports are most valuable, but they are hard to get and impossible to get at scale. Usage experience reports, like user. Usually, we have to make do with the experiences of a small group of self-selected, usually way above averagely capable enthusiasts. That's true. So, like user experience reports, like implementation experience, only experience reports, early experience reports must be taken with a grain of salt, especially when they involve only a single small coherent group. And by the way, like I will point out, I'm not getting this much value from this thing just because of like making connections right now. It's because this paper, despite being 7 pages, is so dense with like points that are so important. Like Bjarne is like seriously. I mean, like if it was weird to call it impressive, considering he's, I mean, like what, like how old is Bjarne Stroustrup? Like man is 75 years old. Like clearly he's lived for a long time and has way more experience than I do. But like I'm just, I, like I don't mean it as like a dig on him. It's just that I've seen so much kind of junk writing that seeing such like good writing, it's just so shocking to me. It feels strange to see writing this good. Like it's so dense, but so full of ideas. Um, ideas that would benefit from being elaborated on. That's for sure. But there's just so much to take from it. But maybe I'm just saying that because my Zettelkasten is very bare right now, and therefore there's more potential for me to make connections from literally anything. Usage, yeah. I've seen this another connection. This same thing kind of applies to Valve, the video game company. They do apparently take their user, like they do lots of user testing or play testing. Sorry, is what it's called in gaming. But they don't just take the feedback willy nilly and apply it. Like they do, if they have a vision, they will stand by it. Um, But that was always weird to me because, like, if you want your players to enjoy it, why would you do that? And I think this is the answer because they just understand that playtesting, even if it's well, actually, even if it's nothing, just playtesting is not a guaranteed. Well, in fact, it's highly unlikely to be a representative representation of the population. What did I say? A representative representation. It's not. It's almost impossible for it to. It's highly unlikely for it to be an accurate representation of the target population. And the only way to really know is to, of course, release it to the public. But even then, like you may get certain reviews, but like those are just a fraction of the player base. So it's really up to developers to decide which ones they want to really take into account. Because the developers also have their own vision. So if that conflicts with what players want, then that's a hard thing to do to figure out. Um, yeah, yeah, yeah. Because um, test groups may not be well are highly unlikely to be, especially at the scale of like C++, highly unlikely to be an accurate representation of the target population of the massive target population. I really wonder how developers go about um, deciding when to take certain feedback into account. Not how they go about deciding, but like what systems exist for developers to go about deciding. Because like something scientific, not just what they subconsciously do. Um, an example is Valve and how they value play tester and in general player feedback, but don't just take it all and implement it. But don't just take, but don't just implement it all. Um, yeah, because like there are times when you need to stand your ground, and I mean I can attest to this even as like a when I back when I was 16, 17, I guess. Because for those who don't know, well, I'm one of the admin of the Discord community, JoJo's Bizarre Modding community. It's this Discord server around 4,000 members, might be more actually. Um, but there was a time when I was one of two admin, the other one being the other guy being the server owner, and I made some controversial decisions. And these decisions were systematic. Like for example, I would choose not to ban a certain user. Instead, I would choose to like try and try out this system. I mean, it's a system we now still have. It's called the quarantine system, and people now agree that it's really useful. Where but like we were only able to get there because I was experimenting with different ways of like handling moderation was the main thing, but also not just moderation, but even like the way the server is designed and like laid out, and like people would give their own feedback on it, and maybe there'd be like a strong consensus in the server, or like at least on like active some well like let's say most active members would have a consensus on oh like they don't like this feature necessarily, but then there'll still be people who actually did like it, but whatever. Um, so that was hard for me because I mean, obviously it's hard. Like it's just like just thinking like, okay, so do I take this feedback, whatever. But it's also hard when you have like actual emotional attacking from because of it. Why did you add? I mean, like if you're a developer, like and like you have a target audience, right? Like you kind of expect like a level of, add this feature. We want this. Like, we want you to do it this way. Like, why aren't you listening to us? So what happens is I mean I did like I did I like I whoa, stuttering, holy moly. I didn't just like shut off and say no feedback, no feedback. Um I took the feedback as it came. I took feedback that I thought was good and implemented it. For ones that I didn't, I didn't implement it, but I still kept it in my mind. And we also had a channel. We have a channel for server suggestions. Um, and then I also decided. I mean, not just me and the server owner. We also decided that we should open up admin applications to get more admin on the team. And now things are fine. I mean, like we literally had a rival modding server spawn. And people were like, "Yeah, we're gonna join this. We're gonna join this other server." What happened was that some of the a lot of the active members jumped ship, but then those who were there like more long term, um, I mean, not all of the long term members, but like I'm saying, like those who weren't necessarily like super active in the server at the time, but still like long term were just wanted to use the server as a resource, like a way to talk about modding stuff. Those were the guys who stayed. Um, and then it turned out like what happened is that the rival server just didn't go anywhere. Like it crashed. I mean, I don't know. Like I tried to join it to see what was going on, but I got banned, which is just annoying. But um, yeah, the server just failed, I guess, and people came back, and now people are happy. Like things have just worked out. Um, and it's not because like I gave up and like just like gave in to what people suggestions were. Like most of the features and the systems I implemented are still there. And maybe they were shaky in the beginning, but then because over time I improved them, they've become very robust. And again, like not to toot my own horn, but like I'm just saying I'm noticing, I'm observing that those have worked in the long term because I stuck out with it. Um, but even with that experience, I can't like confidently say how I made those decisions. Like a lot of it was instinctual. I would say. I mean, like I know what I did to help myself make the decision, which was lots of thinking. I did talk to people about it. Like I talked about, okay, like guys, what can we do? Both in the server, but also both like I even talked to my friends in person. I even talked to my parents because like with I mean for those who have gone in any online community, like you know that like moderation isn't just ban the rule breakers. Like you do have to be like, okay, like what is rule breaking behavior? Is this person actually breaking the rules? Like how do we know for sure? Um, how do we respond to like people who've been hurt and like are emotional about things? Like these are people. Like these are real people, and there's like there's sociology and psychology behind it. So I would talk to my mom literally studied and taught psychology. Um, she was my psychology teacher for the IB, for instance. So obviously I talked to my parents about it as well. And I think what helped me then was just having all this like this data and perspectives is what helped me make the decisions. And then of course again having my own ability to reason about things. Um, but that doesn't give me a system. It just because like it still depends on me being the one taking the input. Someone else in the same situation with the same, I guess, access to like the same knowledge, I guess, would have made a different decision because they just have a different reasoning model. So I don't know for this specifically where whoops where you're deciding which feedback to take into account. It's really difficult to define what's a good system because like for many people like for many good leaders, right? Um, it's just intuitive. Like it feels intuitive, but where does that come from? So, because like it's not just having a good understanding of the population or like, I mean, sorry, it is, but like it's not just I don't know, it's not just anything. It's a variety of factors, and a variety of like understandings, so that you can make predictions about how a system will turn out in the future. Um, and I'm glad that for the most part, my predictions have paid off. But also, like I've had cases, of course, where my predictions don't pay off. But then the ability to then just take that and then learn from it is important. The question is, how do you learn from it, right? So again, like I've said it before, I'll say it again. Programming is such a applicable practice to any field, because like these issues are just so deep, because not only do they involve computational systems, so like it involves math and physics or whatever, but it also involves people, and people are so complex. Um, and like with programming, you're designing systems. Like you have to deal with that directly, and there's no escaping from it. So it's not surprising to me that these seemingly simple statements, right, just get so deep. It is like, okay, wow, I need to like I need water. My mouth is getting dry. It is not just members of the community who wish for just two more features. We have a committee with 300 plus members. What? I thought it was smaller than that. It seems that essentially every member has a feature or two that they'd like to get into the language, and many have several. I have not changed my opinion that adding too many features could sink C++. Remember the Vasa. What? In fact, what is this? I think that the flood of new proposals has increased since I wrote Vasa. I think we are trying to do too much too fast. We can do much or do less fast. We cannot do both and maintain quality and coherence. We have to become more restrained and selective. Um, remember the Vasa. C++ exceptions and alternatives. Wait, is this a book? The Design and Evolution of C++. I swear that's a book I've wanted to get my hands on. Wait, do I have it? Hold on. Do I have this book like on me? I might actually have it, but I just low-key forgot. I have Programming Principles and Practice, which I guess is different. I don't know. Okay, so remember the Vasa? Oh my god. Oh my god. 4 pages, but I'm gonna save this to my reading list. Can I give it a name? Oh, I can't. Um, come on, Vivaldi. You gotta do better than that, man. Is Vivaldi open source? No. Source available. Right. So the Chromium is, of course, open source. Damn it, guys! If you have any browser recommendations, please, because like this is a cool feature, but like, why can't I rename it, bro? Has no one in the Vivaldi developer team made a reading list and thought, hmm, I think that this name for this article is very vague. I wish I could rename it. Like at this point, I might as well just use bookmarks. Yeah, yeah. I'm gonna In that case, I'm gonna keep using bookmarks because I can actually rename those. But also, like, why is the bookmarking feature so weird? Like, I need to I can't just specify where I want it to go. Okay, I can here. Nickname. What? Remember the Vasa. Great. Why is the nickname just not even there? There we go. Uh, okay, I'll look through these at the end. Yeah. Every design has it. By the way, it is interesting that there are more proposals now than ever for C++. Like you think people would just jump ship. Like I'm glad that languages like Rust coming into light are really making people reconsider the mindset of, oh yeah, C++ will just dominate this space forever. Because now people are like, wait a minute, we can create new languages. Cool. Every design has advantages, disadvantages, and limitations. We should never present a design without a serious and honest discussion of possible problems and alternatives. It is part of a proposer's job to examine problems. Pure sales jobs are not intellectually honest. The joint pro and con papers on coroutines written by people from opposing camps were immensely useful. Yeah, from opposing camps. Opposing does not just mean two, by the way. Pure sales jobs. This just stood out to me because I don't like sales because they're not honest. um, I guess that highlights a problem actually with capitalism in general. Because like capitalism kind of relies on you effectively like relies on selling people products dishonestly, or like vastly promotes, definitely like definitely promotes and encourages. Well, yeah, not promotes, but it definitely encourages selling people products dishonestly. How did I just zoom out? And I hate it. Like dishonestly. And yeah, like it just sucks. Like, how do we like? Can we sell people stuff without being dishonest and like without insulting their intelligence? In fact, like we companies literally try to make their customers, okay, well, evil companies, evil customers less intelligent and less capable of critical thought so that they can more easily be sold stuff. Try and tell me this is not destructive to society. It's ridiculous. That's my core issue with capitalist society and why open source is cool. Because open source doesn't lie to you. It just is there. Like it's open source, so they can't really hide anything. I mean, like people can try, and what 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 I mean is that like the open source movement. So like maybe it goes beyond open source, but more like the the community that open source software attracts, that FOSS, free and open source software attracts, is are the kind of people who would not try to sell you something dishonestly. I mean, they would for money probably, as most people would, but if they had to, but there is like a higher moral upstanding, I'd say. The ideal proposal reflects both some theory and some practical experience. We should also be more careful considering related, often academic literature. For major proposals, there's always some related literature. Design involves balancing, an idea. Therefore, we should promote. I mean, think about like news agencies, like with government proposals, right? Think about politics. the people who write their quote unquote, like the alternative of research papers, or whatever, or like academic papers, are journalists. Journalists write papers, they're called papers, right? Like newspapers, whatever, or articles or opinion articles about certain proposals, and then people can. But then the issue is that people usually just refer to one news source, um, and it's kind of it's not easy to refer to multiple, because just a model of how we get our news is very one source at a time type thing, and people don't want to like waste time by just looking through like 10 different sources to get the full story. Ground news is pretty good. I use ground news, but I don't use ground news to like check all of the different articles. I just use it for like a summary, because I kind of hope and pray that it's like impartial, but I have no guarantee that it is. Um, because news sources can be opinionated. So, I mean, with academic research, people do check multiple papers, because like that's in the culture. But it's just interesting how that applies to how it's different with news. Um, so I'll say interesting. Not many red notes, by the way. Any more pink notes? Interesting this how there's a similar idea in politics, i.e., news companies and opinion articles, or like i.e., journalists and opinion articles. Yet there is a culture in academia to evaluate different sources, whereas people reading the news tend to just stick to one source. And like the difference is that obviously like academics need to make decisions or like write papers of their own. So if they didn't like use multiple sources, then they'd just be parroting, or they'd be like, well, like they'd be called out. They'd be called out for it. And surely governments will also look at like different journalists. Well, a good government, hopefully, would consider different views made by different opinion articles, and like use those as some kind of. I mean, obviously, like you would need the journalist to be of a certain reputation to like really consider their viewpoint. Um, but same in academia. If you are a reputable source of good information, then people are more likely to trust you. Um, but for the consumer, they do not care so much. And honestly, I mean, I talk about opinion articles as if they're separate from academic articles, but they're not, because opinion articles often reference, well, good opinion articles or smart ones smart as in like strategic, will reference scientific and academic research, but the difference is that they may bias it. So opinion articles, strategic opinion articles that are strategic will reference um, academic research as evidence of their claims, although will although although there is less culture and what's the word? Not responsibility, accountability, and less accountability, but there is less of a culture of accountability to stop them from biasing towards one source. And to be fair, academia does suffer from the same issue, but people just call it out more. A study may refer to just like these bogus claims from. I mean, not yeah, well, yeah, bogus evidence from bogus studies, or like studies that only support their viewpoint, whatever. Um, that is actually a problem in academic research in all fields. Anyway, design involves balancing different concerns. What the hell? Concerns. Concerns. Design involves balancing different concerns and principles. English, bro. That's what I'm saying, but English is just fucked. There's never a single absolute and unbreakable principle that we can blindly follow. You know what else is unbreakable? Diamond. This is the reason that D&E lists a couple of dozen rules of thumb. What do you mean? What design and expectations? I think. Yep. There's never a single absolute and unbreakable principle that we can blindly follow. Yeah, unfortunately, but inevitably, in the end, much comes down to taste, and crowds don't have taste. What? However, this note could be seen as containing a hidden checklist to be interpreted with taste. What? What? I'm generally just, huh? Um, taste. What is taste? What? Yeah, like what is taste? You know, it's funny because I was. What is taste? I was talking to my flatmate about. Well, she mentioned taste. Um, Look, like how society would be better if we were like taste driven, like if the more tasteful people were put in power. But what even is taste? I mean, it's subjective, obviously, but like even having taste is subjective. I don't know. Recent discussions that prompted this note include major features, concepts, deterministic exceptions, and contracts. Yo, concepts shout out. This was 2019. Yeah, I keep forgetting how recent concepts are. Like they really are just cool. Deterministic exceptions. When are they stochastic? And contracts. Contracts are part of concepts, I think. Aye, aye. Minor features. Uniform function call. Spaceship, which is the equality thing. Not equality, ordering operator, and initializers in selection statements. What are selection statements? How can you be so certain? Someone might reasonably point out. I luckily forgot the title of this paper. Someone might reasonably point out you've often expressed strong opinions and sometimes even sounded angry when people didn't accept your arguments or proposals. I should, of course, not show anger. Oh, like to him. Apologies, dude. Bjarne, Linus, the anger issues are strong, or are they justified? Apologies. When it shows, it is typically the result of impatience after years of work or a feeling that not everybody or every argument are held to the same standard. Also, after years of work, it is hard to be patient with people for whom it is only you. Not only do I try not to show anger, I try not to feel anger, but I'm not a saint and I care about these issues. Yeah, exactly. Well said. Well said. We aren't robots. Yeah, we aren't saints, but we aren't robots either. I'm never 100% certain on the kinds of topics we consider for standardization. I don't consider 100% certainty logically possible. And the only certainty is that certainty does not exist, and therefore accept the need for educated guesses. So far, we slash C++ have not done too badly. I'd agree. Yeah, I mean, I'm not a C++ expert, but I think a lot of the issues that people take with C++ actually aren't as bad as they may initially seem, um, or even as bad as they seem. Full stop. It's hard to be patient with people for whom it is all new. That's really interesting. I'm sure people are at least somewhat familiar with the Feynman technique, or Feynman technique, where you learn something better by explaining it or like summarizing it in simpler words as if you were talking to a child, right? That's useful and even fun, I would say. Um, but if I feel like if you've already done it, you kind of get bored of it. Like, unless like once you start reaping the benefits from doing that, it does like I feel like it does kind of just become a bit like again, like another person who just doesn't get it. Um, Not like because like they're failing to understand. My obviously if you succeed in the FEMA technique, that means that you are able to help them understand. And like that's good. But like if you have to do that like to hundreds of people, um like even if it's successful, it's still kind of just a pain in the ass at some point. And you would which is why I turn to resources that people can access in their own time. Like people like rather than teach someone in a school, write a book, right? And then people can read the book and they can learn about it. Um, and I feel like schools should definitely have like guidance, but like trusting teachers to be banks of knowledge is an idea we should move away from, and instead encourage students to do their own research. And then like students can guide them towards teachers can guide them towards that research because I mean teachers don't even write all the time anyway. Right. Yeah. Oh my god, dude, I'm just saying stuff, and then like I realize I need to actually take notes about it. It's hard to be patient for people who it is all new. Um, Not necessarily because we struggle to explain it, but because it is just a test of patience to repeatedly explain the same concepts to different people. A solution to this is to exist as guidance, but primarily refer people to resources. And likewise, to resources they can access at their own in their own time without human intervention. And likewise, focus more of our own efforts in producing such resources. Yeah. When I am pretty certain that my conviction is usually based on decades of prior art, theory, experience, and thought. Maybe that's the word we need. Pretty perfect. If it's pretty perfect, I take it back. That sucks. Um, Whoa! Decades of prior art, theory, experience, and thought. Okay, because my question was, how do we know when we are like we feel like something's right, right? And yeah, like even Bjorn's here referring to instinct, which is built up on those decades of prior art, theory, experience, and thought. Very interesting. Constructor, slash structure person, RAII. Resource acquisition is initialization. To many, those seem to come out of nowhere in 1979, but they had deep roots in operating systems practice and reflected my inability to express those established practices directly in the languages of the time. I consider this the real foundation of C++. Interesting. He wanted it in the languages, the existing languages as well. It's a feature he wanted. So what did he do? He made you a new language, which is cool. Very cool. Yeah, I guess I'm actually less surprised than. I mean, again, like not surprised, but like less shocked that his writing is this good because like it took someone with real not conviction with real ability to apply systems. Okay, I'm not sure how to phrase it, but like basically, it's no coincidence. It's no coincidence that someone who can write this good was able to, or is responsible for creating a language that is also this good, and like this standing the test of timing. It's a shame. Dennis Ritchie is, I think, no longer alive, but I would like to maybe look into his stuff too. Man, it's just so cool to like look into the inner thinking of people who design systems, because there's so much to learn from how they think. I consider this the real foundation of C++. Yeah, so this is just interesting. I mean, I guess it's expected. Like, why else would you make a language if you weren't if you didn't feel that existing ones were inadequate? Concepts. Yes, dude, concepts. Oh my god. I started looking at the ways of specifying arguments for generic types and algorithms in the mid 1980s. See, concepts are not a new idea. He's had this idea for since like conception. That's crazy. That is crazy. And they only got added in C++ 20. Like, what a time to be alive, where concepts have just been added. Like, are we dead ass? Before that, I had found that the macro-based techniques we had used in the early years of C++ didn't scale, and I followed the literature for more than a decade. The current design has its roots in work from 2003 and even earlier. That's crazy. Again, C++ 20. That means 2020. Wow. That work involved experimentation, of course, implementation, and academic publishing. Committee papers, use, teaching, etc. I don't see significant improvements to users as opposed to experts, whatever, post 2015 or so. I consider concepts a necessary completion of the design of templates and an essential part of the support an essential part of the support of generic programming. So that makes you wonder because people have had issues with templates since it came out in C++ 11, if I'm not mistaken. No, templates, no. Templates have been around for longer, haven't they? When were templates added to C++? Like a core feature, no? Yeah. I forgot what C++ 11 added though. C++ 11 templates. An alias. Um, there was something that was added in 11 specifically. Oh, lambda expressions. And constexpr was what? Yeah, okay, that's right. I constexpr. That's right. So but I wonder if people's issues with templates have just been because they've lacked. First of all, constexpr came out in 11, and that lots of people haven't switched to 11. In fact, people now, when C++ 11 came out, what? No, nowadays people consider like the earliest usable version of C++ to be 11 because it has constexpr and other really useful features. And I think now, I wonder if the same will happen with C++ 20 because of concepts. Because people have had issues with templates for ages. But Bjarne is supposing that concepts are the thing to finish off templates. Like templates seemed problematic because they were incomplete. And that is very interesting. And it's also interesting to see how concepts, given they have existed for, well, as an idea for so long, how they compare to traits, because they are different. And Zig actually leans towards concepts, which is also very interesting. I don't see significant improvements. Users, yeah. So I wonder if this is why people have had issues with, like, have taken issue with the idea of C++ templates for so long, and whether perspectives will shift as concepts become more mainstream. Is I guess how I would phrase it. Exceptions. The issue is to inflate. By the way, if you there's a video of for concepts by Bjarne. Um, it's a bit long. It's a presentation, but it's just so eye opening to the power of concepts, which is why I keep going on about it because I just love. I don't know if I love it, but like it's just so like novel to me. Coming from again, like traits exist, but like to me, they look like traits, but potentially more powerful, and that is really cool. I need to explore that further. The issue is too inflamed to discuss in detail here, but the roots of the problem are in the multiplicity of error reporting mechanisms. Yeah, okay, there's errors. Exceptions. Exceptions are not great. I don't like exceptions, personally. I think algebraic data types are just better. But also exceptions are, I don't know how they're implemented, personally. But I don't even think they're necessarily that different from algebraic data types, or sorry, from result types under the hood. I could be wrong, but I would expect they're actually quite similar. It's just the abstract model and the abstract model of having the type signature reflect the error potential of a function just makes sense. Um, I know Bjarne, like I was reading the C++ language. I think the C++ 11 edition, which is old, by the way. Um, a lot has changed since then, and yeah, he talks about exceptions like this really cool feature, but clearly people have are now disagreeing, and I've wanted to know what he thinks about that. I mean, this is 2019. I really want his updated opinion on exceptions and what he thinks about algebraic data types. Because personally, I'm fully in the algebraic data type camp. I think exceptions have no use. Um, in a language where the standard library for like core functions, like opening a file, for instance, are use the result type as well, because they can. Like if they can throw an exception, then they can return a result type. Like it's all deep. The discussion and research go back to contracts, which are related to concepts, right? The use the use of invariants of various forms go back to Peter Narr's work in the mid-70s. Much modern thought reflects Bertrand Meyer's work with Eiffel. Sorry, I should probably make a note of this. I am really curious as to what Bjorn's updated perspective or opinion on exceptions versus result types is. Because, yeah, I mean, it's exceptions or result types, and anything else is a lie. You know, like Go's way of doing air handling is just weird. Like, why would you have just like a tuple basically? Like what? Like just make it a union, because like the whole point is that it's one or the other, like conceptually, and it's I don't get it. I don't know why you would prefer that unless you just literally don't understand how a union works. Much modern thought reflects with Eiffel, both imitating it and opposing most aspects of it. Cat-calls and class invariants. Other roots lie in decades of work on static analysis, supported by assertions and interface. What the hell? Sorry, why is it highlighting like that? Uh, Bro. Okay. Other roots lie in decades of work on static analysis, supported by assertions and interface specifications. Static analysis is a lovely, lovely area of research. The work involving continuation, on the other hand, is relatively novel, backed mostly by logical arguments and experience at Bloomberg. Note that before the failure of the proposals for C++20, two previous attempts had also failed. We should consider why. Okay, maybe I don't understand contracts. I'm thinking of constraints. What are contracts? Are they to do with like 26? Oh my god. Contract assertions allow the programmer to specify properties of the state of the program that are expected to hold at certain points during execution. Ah. Um, I recognize this idea, but it low-key just crashes the program. Like its runtime. Yeah, during execution. It's runtime, for those who can't see. It's runtime, and I think that's kind of pointless. Because, like, like perfect software or safe software doesn't crash. Um, like, there's no point in making memory safe software if it crashes. Like, maybe it can crash gracefully. But like generally speaking, we just don't want our programs to explode in our faces. Um, I mean, like, doesn't STD does doesn't calling standard terminate just like in the middle of a thing? Like, that's not really graceful anyway. Graceful would be reported like finding the error, reporting the error with result types. I don't know. Operator dot. One of my fundamental aims for C++ is, from the very start, to provide equally good support for user-defined and built-in types. Yeah, this was a big part of his talk on concepts. For example, I'd like to be able to build an integer type that is as good as a built-in int in every way. I am yet to see a language that achieves this, with the possible exception of compile time. For types with public members, the lack of operator dot leaves a gap in how such types are controlled and accessed. For example, I can't build a simple and general smart reference, a proxy. The very first extension proposal in 1980 was for an operator dot. C++ is not complete without operator dot or equivalent. Um, I mean, my argument is to just not have dot notation at all. I don't like it. But if we instead treat dot notation as not a not a feature of classes, but as a general feature, like the dot operation literally is just syntactic sugar for put the left side in as a referenced first argument. So then, like, if I have a function that's like add int a int b, then it will literally which like then I could do like a dot add b, and that would just work. No overloading, no nothing. Like it just is the operator, and like that's what it does. In a similar way to how the brackets operator for arrays, like it just expands to the dereferencing a plus b, right? But that is where I would see. That's where I would be okay with operator dot. I do not like operator dot as a class level concept. And like again, like this is what I mean by atomic features. If instead of making like operator dot specific to classes or structs, um, just make it global, or like at least consider what if it was just a global feature. Or if you do make it, then keep it atomic. So like it's still specific to classes, but if you wanted to, as a language designer, you could down the line change it. I don't know what C++ can do now, but yeah, that's what I want to see. But ultimately, I don't care too much for dot syntax anyway. Unified function call, the notation distinction between x.fy and fyxy comes from the flawed O notation that there always is a single most important object for an operation. I made a mistake adopting that. Yo! It was a shallow understanding at the time. I mean, exactly, like if you have a dot add b, like that's just confusing. Like why don't you just do add a and b? I mean, no one does a dot add b, but that would be the issue with having dot notation global. Even then, I pointed to square root of 2. and XSY as examples of problems caused by that view. With generic programming, the blah, blah, blah distinction between a library design and usage issue. With concepts, such problems get normalized. Again, the issues and solutions go back decades. Allowing virtual arguments for x of x, y, z gives us multi-methods. Okay, I don't really understand that. I want to know more about what he means. Because again, like, it's a case as to why we shouldn't have global dot notation, but then it leads to this issue here. Like if you want to overload the dot operator for int, I guess, but like how are you overloading the dot operator if it's not like a class? Oh, I don't know. All but I mean, I guess you could just make int a class. Anyway, all but contracts are part of my long-term view of what C++ should be. Oh, so does he not like contracts? I kind of missed that. Oh yeah, the work involving continuation is relatively novel, backed mostly by logical arguments. Yeah, I mean continuation is important. Okay, I'm not really gonna make notes on these, but they are interesting anyway. All but contracts are part of my long-term view. The static analysis part of contracts belongs there. I don't dislike the runtime checking part of contracts. I just can't claim them as part of my long-term view. Though of course I need a contract. Why not? Why? I need to know. Is it because they crash at runtime? I cannot. Conclusion. I cannot offer a simple code conclusion. I don't think there can be a simple set of rules that anyone can follow to ensure a good design. This paper was motivated by the quote from a great empiricist urging intellectual humility, which was at the beginning, almost 3 hours ago. Elsewhere, he warned against theoretic/academic notions that have not been validated by observation of nature. In a sense, that is the conclusion. That is the conclusion. Don't be too certain of your facts and theories. Search out facts and work to develop a theory that match the facts. Search out facts and work to develop a theory that match the facts. So you could say abstract, don't. Abstract from, don't abstract to. Oh, that's a terrible quote. Yeah, cool. And then references. These are GitHub. Yeah. So somehow I already saw these. Maybe I actually got these from the thing. Bro, who is Herb Stutter? Editors, Bjarne, and I'm like, I know who he is, but like, how big of a figure is he in C++? Like, all I knew him for before this was that he was the guy who um, is helping with a patch matching a proposal. His blog goes back to 2006. Bloody hell. His blog is almost as old as my thing, and his oldest post is Stroustrup and Strutter. Clearly, they go way back. God damn. Free as in beer, books and love. No way. No way. So you're telling me that the open source movement was what started Herb Sutter to make his first blog post. Nah, there's no way. Okay, no, it's different. It's different. It's different. That is scary. That is scary. Oh my god. No, he's referring to like to bribery. People giving free stuff for bribes. Um, I'm an author and speaker and a programming Language nerd. His focus is on enabling program code. God damn. All right, Hoopslasher. Your name is now cemented in my mind. I must look at this book. C++, Exceptions and Alternatives. 2019? I want a more recent one, but I will definitely look at this if I can. Exceptions are necessary, as are error codes. Okay. Must see. Must read. Must read. Revision 0. Can I... How do I know if it's the latest revision or not? Like, there's no... Uh, get paper. Get latest public revision of a paper. So I just do wg21.link / this. Right? Okay. I need to remember that. In fact, I'm actually going to pin this because I will forget. Okay, save this for later with a name I can actually read. And what is this book? Was it in collaboration with? No, it wasn't. It was in Chinese. Let's go. How old is it? 1994. Okay, that is a That's a worthwhile read. And it's on GitHub. So Jesus Christ, why is it in Chinese? I'm guessing it's not meant to be. £44. Yard. £9 used. Okay, that's better. Uh, it won an award. Is this a book? Surely it's more than 48 pages. Yeah. This is like a preview, right? Uh, okay. I'd love to read this one day, but for now, whatever. Well, there you go. I've finished the article. That took me a whopping 3.5 hours, but I'd be damned if it wasn't insanely productive. I have literally not felt more productive in ages. So yeah, got a lot of notes here. I don't know if I can like view my notes all at once. Probably not. Mind you, it's saved to the PDF. So if I were to open this PDF, would it have the notes? It does. So I can technically like run this through some other software. Let's have a little inspection actually of a PDF because maybe I can make my own tool in that case. Uh, I'll zoom out here. So you got header, comment, okay. Body section, conventional. What? I don't know what this template even is. Okay, so how does it work? How does it work? How does it work? We have decode params. This stuff. Why is it just like junk? Is it encoding? Let's look at UTF-8. No. Do PDFs like utilize compression? And that's why it looks like this? Yeah, it's definitely not in Chinese. Okay. Interesting. But either way, it looks like I can see my comments in this way anyway. It's pretty cool. I wonder if I can display it in this way, why can't I just make it here? Why is PDF viewer so bad? Oh, and okay, I can hide annotations like this. How is this not a feature in Ocular, bruv? Okay. Yeah, I think I prefer this for viewing it. I need a better workflow for Vivaldi, but cool. I almost wonder if these boxes, like if that box is even a PDF feature, or if it's like some custom CSS way of just showing a box and hover, and like it's been baked into it. I don't know. You know what? It doesn't matter right now. Well, there you go. Obviously, I need to go ahead and I said obviously so many times. I do need to go ahead and create notes of these now. Put it in my Zettelkasten. Oh, but it is 9:30, and I need to make dinner, or I'm gonna starve. So I'm going to do that. I'm going to do that, and then I might record later today. I might record me doing that because I want to document that process of me creating notes in my Zettelkasten. So I'm going to do that later. Either way, it will be recorded. Yeah. Anyway, but like once again, I've already said it. I'm amazed at how productive that was. Oh my days. Um, Diego Brando. Ah. Um, yeah. Just end the video, bro. Just end the video. I don't know why. Is there something else I want to say? Um, Bjarne is cool. Yeah, I don't know. I'll just pick this up when I. Yeah, good progress. Subscribe. I missed the record button.